Hello everyone, I hope you're all doing wonderfully well. We have another excellent interview booked for today. This is an RAF airframe technician. Hello Martin.
Hello, how are we?
Yes, okay, thank you. And I hope you're well too. I know you're a busy man, but we got you. Now, let's think, how did we meet? You invited me to Bruntingthorpe, was that right?
I did indeed, yes. And it's probably a good job that we did that when we did.
It's so sad. So sad.
Yeah, that's all gone the way of the dinosaurs now.
So let me try and just fill the viewers out. So myself and Martin, are very lucky, and sometimes you just don't know how lucky you are. We had an old airfield. It's not used as an airfield really anymore. Near us, called Bruntingthorpe, and twice a year they used to hold 60s, 50s, 60s jets. They're Cold War jets, shall we say, and 70s and 80s. And they used to do fast taxi runs. And you're probably thinking, fast taxi runs? That sounds boring. I can assure you it's not. This is better than an air show. This is freaking awesome. Because it's fast taxi runs only, you don't need the strict regulations of a modern air show where you can't get within 3 miles of the bloody aircraft. They used to get right up to the aircraft, even when they're running, get right near them, and they'll go full power right in your face. And it was dirty and smoggy, and it's like a really... even made like a drag race strip look boring. Really exciting stuff, and they'd run all these cool planes up and down, and keep lots of people really satisfied, and it was just awesome. And again, I never really took full advantage of it. I've been like 4 times or something like that, and it's unfortunately shut. Are we allowed to know why, or is that not a thing?
Yeah, I mean it's out in the public. Now, essentially, the airfield's been sold to the car auction owners who were taking up most of the space anyway. And they have very little interest in the aircraft side of things. So most of them, who aren't owned by the original airfield owner, are being sort of kicked out. The Buccaneers recently did a road move down to Kemble, and they're parked outside the hangar I'm doing my course in at the moment. The ones that are owned by Dave Walton, the airfield owner, are still there, and the plan for the future is set in jelly at the moment, essentially. But with there was planned to be a limited sort of show, hopefully, with the as a part sort of publicity for the automotive people at the end of August as usual. But obviously the pandemic paid to that, and the fact that there are so many cars there at the moment that they are taking up the entire airfield. So yeah, the whole thing's gone a bit on the back burner at the moment, unfortunately. So it's a good job we took you there when.
Yeah, absolutely. It was really amazing, and I'm lucky. I'm peed off that I didn't make more use of it. But yeah, I guess you could say that about any air show and place. But I'm also glad that I did it, because I have that memory. No one else is going to, you're just not going to be able to get those memories anymore of how cool that day was. But at least we've done it, and I've got some. To immortalise it, I've got some videos, some limited videos that I did of it. So at least it's still in the memory there. But that's life, unfortunately. And this is it's so frustrating. But this is the way of historical aviation. I'm lucky living where I am, and you yourself as well, that we are surrounded by amazing bases. Mildenhall, Lakenheath, used to be Alconbury, used to be a whole bunch more. But as the world's becoming safer, I know this is a stupid thing to say, the world's becoming safer, especially for the West, these, they're all dwindling and going. And slowly we're getting less and less and less fighter planes or military planes, and less bases. They're all shrinking away, all disappearing, turning into car lots and housing estates. So it's good, because it means we're not going to have nuclear bombs dropped on us. That's nice. But for aviation, especially historical aviation, everything's going, and it's really sad. But it's just how it is.
At the end of the day, no one wants to watch a UAV do a fast taxi. But
yes, exactly. Yeah, exactly.
But for anyone who wants, those videos of that day are on the Grim Reapers channel.
Yeah,
it's worth a watch. It's something different.
It is something different, and it's become more and more rare, obviously. But anyway, that's how it is. That's 2 old guys moaning about their past disappearing, but that's the way it goes. Let's talk about you. So I'm going to read your synopsis out. So I joined the RAF in 2000 as an airframe technician. A few years later, I added propulsion to my trade, so I work on anything that isn't electrical, avionics, or weapons. This includes structures, airframes, repairs, hydraulics, landing gear, AC, pressurization, flight controls, oxygen, engines, and fuel systems. It sounds like a lot, but many of the systems are crossover anyway. I worked on the Nimrod, very cool plane. If you don't know it, go and find it. for 7.5 years. Tristar, cool plane, for 5, and briefly on the C-17, not so cool, but okay. And the last 5 years on Chinook, which is a cool plane, chopper. All very different beasts and enjoyable in their own way. I'm currently studying for my civilian maintenance license through work, and that's cool. So this is, for me, this is really interesting. I don't have the qualification, skill, or anything to go and do this kind of stuff on aeroplanes. I sort of do it a little bit on cars, and so I can imagine how cool it must be to do properly on aeroplanes. The questions are thought by you guys. They're not checked or anything by us. We just let you ask whatever you want. Hopefully there's no rude ones in there. So let's belt off with question 1. Does the RAF ever do incentive rides like the USAF?
You do find that on fast jet squadrons, so Tornadoes it was, Typhoon or whatever, if you've got someone who's been on there for a long time and is then leaving to go somewhere else, they do try and get them a backseater or in a Typhoon, like a 2-seat ride. They're not that common, and there's a lot of regulation surrounding it. You can look at the Red Arrows incidents for starters, because the engineers there frequently ride in the back of them between air shows, and it's like that's one of the things the engineers build up to in their 3-year tour. They have to do the 2 years first, and then they can be selected to go and be on the circuits and fly in the back of them. Incidents have brought up the legality of that and what they're actually classed as. So it's along with making like the medical requirements for an ejection seat, etc. It does happen, but it's not just a case of I think I want to go flying today. Excuse me, boss, can I have a back seater, please? It's because they would be very sought after at the end of the day. I've never had one because I've never been on a fast jet squadron, but I have done a lot of flying with the aircraft I've been on. Mainly due to my job, because you tend to fly on them if you're going places, but obviously it's not quite the same. No one is saying that flying on the backs down the back end on a Tristar from like 12 hours from England to America or whatever is quite the same as doing going through the Mach loop in the back of a Typhoon. But I enjoy flying. It's so I've generally taken up the opportunity to do it whenever I could. And also, for me, because I'm a bit of a nerd, that's why I'm here, I like to see how the aircraft is working in flight. It's all very well walking on board. You see, dead aircraft, cold, no gauges working or whatever. You can power it up, but it doesn't necessarily give you an indication of how things look and how things work in the air. When, especially if the aircraft are having problems, they've got a lot of things to deal with. Whereas if I've got a problem on the ground, I can just concentrate on that. I don't have to worry about anything else. So I always like to see how things operated in the air. So I've done a fair bit of flying, but it's not quite the same as you would do on a fast jet squadron.
The idea of going up in the plane to actually check how it flies, and to that helps on your, say, diagnosis and prognosis and whatever. Is that idea actual official doctrine, or is it just something you personally like to do?
So generally, I've been a couple of times. I've been up with an aircraft. It's quite a rare thing to actually send an engineer flying with it to help diagnose something, because generally, if there is a fault, you don't want it flying. So it's very sort of limited circumstances that might happen. I have done it on with a hoist on a Chinook, like external rescue hoist, where we couldn't reproduce a fault on the ground. And because it's not something that's affecting the flying characteristics of it, you say, okay, go and get the aircraft, go and do the load test on it with the weight, and you can go up with it and actually see what it's doing, and see what the system is doing when it's got this fault if it reappears. Chinook, it's a bit easier because they can just land, got the ramp, get on board, and away it goes. Normal aircraft, because you've got startup, taxi, whatever, you have to shut down to get people on board. It's a bit more complicated. But Chinook was a bit easier to work on, so it does happen. But the actual circumstances that you'd be required to do that are quite sort of thin on the ground, because most things you can operate and replicate on the ground in one way or another. It'd be like saying I've got a braking issue with my car, but only from 70 miles an hour, and so you have to go out and sit in the car on the outside of it while someone brakes at 70 miles an hour to try and diagnose it. It's not ideal. So you try and do it in the garage, get someone to spin up the wheel, that sort of idea. It's it's not ideal.
Very good. Okay. 2, have you ever dreamt about being a pilot when you were a technician, or were you just happy being a technician?
I mean, I like flying. I like having a play around in the plane. I started my PPL about 10 years ago, 12 years ago. Discovered just how expensive that was, and decided that unless I was planning on making that a money earning hobby, if you like, it's going to be very expensive and a lot of work. I'm not going to lie, and I think possibly it may have sort of ruined my enjoyment of the actual flying. So although I did want to join the Air Force as aircrew, I couldn't have been a pilot because my eyesight wasn't good enough. That was just a factor at the time. I've since had my eyes lasered, and they're now perfect, but way too old to do anything like that. And my story sort of fits in with what Tim Davies was talking about, actually, where just because of the environment I grew up in and with the person I was like back then when I was like a teenager, I thought I was just going to follow my dad, go and be aircrew. It would be a piece of cake, get through selection, find the Air Force would be crying out for me. Why wouldn't they be? It turns out they weren't. So whilst being sort of walking back to my house with a tail between my legs after that, I decided, well, I can either try again in a year or just join up anyway, and then you can reapply for aircrew or commissioning or something like that whilst you're in, and it's quite a common thing to do. So I joined up as a techie, so I could at least still be with the aircraft, and I enjoy engineering and getting my hands in and everything, but it's I just sort of procrastinated really because they kept on paying me at the end of every month, so and I never quite got around to sort of reapplying for it, which I do regret. But here I am 20 years later, I'm still in the Air Force, I'm still doing the job I actually enjoy, so
Roger.
Yeah, it's I'm not going to complain about the way that things worked out, but it's what Tim was talking about. If you want something, you have to prepare for it. You have to go out and actually put the effort in and everything. And I didn't when I applied for it.
Yeah, fine.
So yeah,
that's fine. I personally, I never. I with my wisdom now, I realise that I never. I don't know if I could have, but I never should have been a pilot. I'm just not suited for being a military pilot. But I would have loved to do what you do. I would love to, whether it is on fast jets, helicopters, whatever. I'd love to be on the nuts and bolts mechanic side. That's where I would have belonged. I reckon I would have done a really good job on that. But anyway, that's a different turn, maybe in another life. But yeah, that's why I love interviewing you guys. I've had some great interviews, really best interviews I've had are just guys who clean the tyres and stuff, and you find some amazing things about aeroplanes you never would have even thought about. Absolutely fascinating stuff. As that, I did have something else to say on that, and I've forgotten. Oh yeah, but the private pilot's license. Okay, a lot of people say, "Hello, Cap, when are you going to get your private? You know what I'm trying to say? My pilot's license and go and fly my Cessna or something." Do you realise how much it costs? Tens of thousands of pounds. I've looked into it. Tens of thousands. Never in a million, unless I get a millionaire Saudi backer on my Patreon, which isn't going to happen. It's never going. It's just not possible. You've got to.
No, I think also when you get into that situation, it becomes so much more than just the flying. It's like I enjoy get a bit of flight simulator, a bit of DCS, and just sort of prat around with it or whatever. You can't switch to an external view on a real aircraft. You are having to actually speak to air traffic. You are having to look outside and see what's going to crash into you. You've got your aircraft systems, you've got your planning, you've got your drift calculations, your navigation, all those sort of things that you don't have to worry about when you're actually just sort of prattling around with a plane in a flight sim. I think there's so much more to actual aviation than just flying it, and that side of it is what I actually enjoy. And yeah, I think to an extent, if you try and make your hobby your job almost, you can sort of quite possibly sort of fall out of love with it.
Oh, you can. Well, I mean, I'll see no all about that. we have to put a brave face on a lot of the times. But yeah, no, you're right. Never make your hobby your job. Learn from Super Cap and mine. And never mind.
Yeah. And also, I think flying like business class is much better than possibly being in the cockpit and having to actually work at that point. So yeah, that's the route I go down, I think.
Amen. Okay, very good. I don't know how you're going to answer this, but have you ever prevented a crash in any way? I mean,
it's an interesting one, that one. I had to think about that one quite a bit, because there is very little actually preventable, I think, that would cause an aircraft to crash, and that's mainly because of redundancy. The more aircraft have come on, the more redundancy and that they have built into them, so that one single failure won't cause a crash. Like going on Tristar, there's two different ways you can lower the undercarriage, and one of them is purely gravity. So that even with even if you have a complete hydraulics failure, you can still lower the undercarriage, which is what surprises me about. There was a 767 a couple of weeks ago, which they couldn't get one of the gears down.
I remember.
And and it's not the first 767 that's had that issue. There was one, a Polish one, where they couldn't get any of them down. And I haven't looked into what they decided was the cause of it eventually in either of them, but it seems odd to me that it would be completely unable to get it down.
These are completely separate systems, aren't they? Yeah.
Yeah, and it's like literally the gravity one is literally like a series of handles in the flight deck. You lift up a cover plate, you pull this handle, and it just puts all the hydraulic circuits into a runaround condition, so that instead of hydraulics holding it up, the hydraulic fluid can move to wherever gravity wants it to, and so nothing is holding the gear up, and so it just falls down and literally pushes the door out of the way. There are no hydraulics needed, so I can't imagine a situation where that would happen, where you couldn't get it down at all. But I don't know how the 767 works.
So there must have been... Sorry, go ahead.
Yeah, so a good example is the DC-10 that basically lost all its hydraulics because the center engine gave out, and they basically landed that. I say landed in the loosest possible term, just on the engine thrust. And now that had 3 hydraulic systems to it. The Tristar's got 4, and all 4 systems are used to power the flying controls. So it's not a simple case of all of them power all the controls. There's a bit of a mixture going on, and the diagram for it is horrendously complex. But essentially, you've got your 4 systems: A, B, C, and D. And let's say your left outboard aileron works on A, B, and C. Your right outboard aileron might work on B, C, and D systems. That sort of idea. So by losing 3 out of your 4 systems, you've still got control of the aircraft. And there was a situation where the number 2 engine in the Tristar gave out, and at that point it is down to 1 hydraulic system. But you don't want to be in that sort of situation. So the hydraulics that broke the rudder was A, B, and C systems. The number 2 engine had pumps for B and C system. So if your number 2 engine gave out, you lost them anyway, so forget about them. But you don't want to lose the A system if you can avoid it. So there's a tiny little valve in there, in the A system, up near the rudder, which, if it sensed a pressure loss downstream, would then immediately shut off. So you wouldn't lose A system either. So you still have 2 working systems. And that sort of redundancy is why aircraft are basically it takes a lot for them to actually crash. So it's very rare, I can imagine, a situation where when you're servicing an aircraft, doing after flight, before flight, whatever, where you're walking around and you find something that would cause a crash. I personally never have, but I think that all the work you do, in a way, prevents a crash. But they have so much redundancy built into them that it's unlikely to find one single thing that is going to cause an aircraft to crash. So I'll take them all high ground and just say that everything I do prevents a crash, maintenance-wise.
I found that interesting. I never really thought about it, how redundancy is such in the doctrine of aviation from the ground up, clearly, and how different that is from automotive. I guess it's just a fact that an aeroplane is in the sky and can crash. A car, lorry, whatever, is not in the sky and can't crash as such. And because I can't think of anything that's got redundancy on my car. Anything I take out, remove a wheel lug.
No, it'd be like having 2 steering wheels in it or something like that.
Yeah, I guess you just Except that if most things fail on a car, you're going to be okay. You'll just pull over. Whereas if anything fully failed on an aeroplane, then it's probably going to crash. Interesting.
Yeah,
What's
it's
the number one system failure on an aircraft?
Say again, RC?
What's the number one system failure on an aircraft that causes crashes?
Pilot.
Yep, that's it.
Yeah, knew that
yeah,
one.
Seat stick interface, definitely.
Yeah.
But I mean, I've made mistakes in my time. Everyone makes mistakes. It's a fact. But yeah, it's if pilots get them wrong, they tend to be a bit more serious. Bit more serious, shall we say?
Okay. Good. Okay.
Yeah.
Very good. Let's push on. Out of the 4 airframes, I guess, that you've worked on, which has been the easiest to work on, and conversely, which has been the hardest / most annoying?
Yeah, it's a weird one, that one. So it's always been a bit more difficult. Chinook was very intensive, and everything either needed a crane or 20 people to do it with, or some sort of support equipment, just because that's the nature of helicopters. Tristar was, if you had to do something big, then you needed a lot of stuff, like removing an engine needs a lot of ground equipment. But generally, the work on it was quite simple, if you like. It's because it's an airliner, it's designed to have sort of minimum maintenance on it. Nimrod was more. It was an older aircraft, so a lot more. What's the word I want?
Agricultural?
Susceptible. Well, definitely agricultural. Yeah, definitely a lot more susceptible to things going wrong because it was like less computer controlled and more mechanical. On the plus side, you could see what was going on. It's not a computer box that's operating something. You've got all your hydraulic valves there, and you can see inputs going into them. So things could be a lot easier to work on. But it's they've each had their sort of up and down side. But Chinook was definitely the more maintenance intensive. And it's always a good way of analysing it is looking at the amount of man hours you have to put into it per flight hour, and from that, although I don't know the figures involved, but Chinook would be absolutely massive.
Really?
Because just because the amount of work you had to do on it and the amount of flying they did, maybe a few hours at a time. Whereas TriStar would quite happily be, how far are you flying today? 12 hours to Vegas, and then back again. And there wouldn't really be much necessarily to do on it as long as nothing broke. So yeah, it's very different worlds. But yeah, I'd say probably TriStar's easiest. Chinook's definitely the hardest.
You must feel sorry. You must have some sympathy for people like Ito, who's just joined the Twitch stream. He, I forget if he's a chief or what he is, but he's essentially, he works on F-16s. And they obviously designed the F-16 with the last thing in mind is the ergonomics of the mechanic doing the work on it. And so everything they do, they're upside down with their head in a little panel and their arm, like wrapped around some air conditioning unit or something. Whereas I imagine something like anything commercial is going to be much more designed to be worked on.
To an extent, just because they're bigger, there's more space. But Nimrod was quite the same, especially mainly because it was a converted airframe. There are some parts of it, especially if you wanted to get in amongst the brake circuits, like all underneath the rudder pedals and everything. All the braking valves and everything were all situated there. So you basically had to go into the nose undercarriageway, take off a panel there, climb into the radome, making sure the radar wasn't turned on, otherwise you'd just end up looking like a green mush. And then take off another panel from the pressurized side of the aircraft, and you could just about get your head in there along with your shoulders. And in there was the stuff you're trying to work on. And some of the bolts in there, you just think, they literally put this bolt in place and then built the aircraft around it. Because some of the stuff was just horrific, but that's what you get when you take an airframe and then add stuff to it.
It's a really interesting case, that, isn't it? That was, hang on, let me see if I get this right. It was a Comet. Was it a Comet?
Yes.
It was a Comet. Everyone knows the Comet, obviously, probably for worse reasons, but it was a Comet, and they wanted to turn it into the military aircraft, and so I don't know what the best way of explaining this is. They almost added a separate fuselage, didn't they?
Yeah, basically they basically added the bomb bay underneath it.
As in literally added to the Comet. It's very odd.
If you look at it from the front, it now looks like a number 8. I think they call it like a double bubble fuselage. But essentially, when you go into the bomb bay and you look up, that is the bottom of the Comet. And it's a massive amount of modification to it, but it worked.
Roger.
But it just means it means that maintenance-wise, some things are horrific to get to.
Roger. Okay, very good. I've just said the AV8B has the worst maintenance hour per flight route. I bet it does. That Harrier, God, what a nightmare.
I can't imagine that. Actually, to change the engine, you have to take the wing off, which is
whoops.
It's not something I've ever had to do on anything I've worked on. But
Speaking of that engine, there was a bunch of Pegasies, that's the plural. Last time I went to Bruntingthorpe, next to the Starfighter, I saw a load of Pegasi there, just sitting there, rotting away in the rain because they had nowhere to put it. I found that absolutely fascinating. Just you can go and spin all the wheels and stuff on it. I found that really interesting. But anyway,
a good one actually is I went to Davis Mountain Air Base a couple of years ago on detachment for a couple of months, and had a trip around the boneyard. Yeah. In fact, I sent you that picture of the B-52, which had lost its tail.
Yeah, amazing.
And in one corner there is just a rack of Harrier wings.
Wow.
That the States bought off us when we got rid of ours.
Yeah.
And they're just out there, lined up on a rack, waiting for them to need them for their Harriers.
Was that for the AV8Bs then, or whatever?
Yeah, which is slightly depressing, I have to admit. But they just said, spares packages, yes, we'll have them. Bring them over here.
Yeah, one thing you don't think about when you think about aircraft, you don't think about the behind the scenes. You've got to have all the spares for that aircraft. I guess a good example would be countries that can't get spares, like Iran. Have all their Tomcats and stuff and their Phantoms, and they just, for political reasons, they haven't been able to build up their stocks of spares, and of the massive problems that it causes, obviously. So it's not just having an aircraft; you got hanger loads of spares sitting there just in case. It's interesting. Yeah,
spares and industry support, manufacturer support.
Yeah.
I think we talked about all this when I did that fatigue interview last year.
Yeah.
That the support for aircraft is one of the biggest issues. It's why the Vulcan stopped flying when it did. It's why you can't just go and fly anything you want in the UK.
Yeah.
Because everything has to be approved and must have a design authority behind it.
Mm-hmm. Yeah. Okay. And there's a good reason for it. It's just how it is. Right, let's punch on. I heard from other maintainers working on fast jets that one of the big causes of extra maintenance is if a pilot over-Gs the airframe and then everything has to be inspected. Are there any equivalents, must be in the helicopter, things that can cause those kinds of major inspections in the world of helicopters? Bet there is.
Definitely. So, if anything, they're more susceptible to it. Because you can make a helicopter do some ridiculous things that it shouldn't be able to do. It shouldn't be able to fly in the first place, but they do anyway. And you can do some really serious things with them. So, excuse me. So what the Chinook uses are basically what's called strain gauges, which basically measure the amount of or the rate of input into the swash plate, and the swash plate is basically what determines what angle your flying controls are working at, and that strain gauge is basically a fixed link which has got electrics on it which tell you how much strain is going through it. And that is translated into a cockpit gauge for him, which has got a green band on it, and then a yellow band, and then a red band. Essentially, you can do what you want in the green band. If you go to the yellow band, it's okay, but try and get back to the green band. And if you go into the red band, then basically just come back here, land, tell us, we'll have a go at you, and then we'll go out and see what's actually happened to it. And it's basically a case of how much force you're putting through it. So how much movement in how quick a time are you asking the swash plate to move at to change your the angle of your flying controls, and that is basically deemed the G meter, if you like, of the aircraft. So if you're flying along and at low level and you suddenly see some power lines or whatever, and you haul up on the collective to get a huge amount of lift in all of a sudden to get over them, that will translate to a massive movement on the gauge. And that is, if you like, what is putting all the stress through the aircraft, because the rotor blades will change pitch, the thing will lift up a lot, but all of that has to go through the transmission and the airframe. Now, the gauge just goes back to zero when it goes back into the green, but the computer records it all. So when we download the card afterwards to make sure there's no faults with the aircraft, it comes up with a big flashing warning light. The pilot got to this amount in the on the strain gauge. And basically how bad that is depends on how much maintenance we need to do. And it's generally broken down into go to some inspections. If you find anything wrong, then you have to go into much deeper inspections and rectification. If you don't find anything wrong, fine, return to flight, etc. But yes, helicopters suffer from this as well, if not more than normal aircraft, because of the way they fly. Even all airliners have this as well. They have lots of sensors all over the place that are measuring G and acceleration and everything, but you'd have to do something quite bad for them to actually pick it up on.
Theoretical. Let's say a pilot's done an air display, he's gone into the red, apologises profusely to you and your men, and you get the data card, and it says, yeah, it's gone into the red, and you go in and analyse. You said, if you find something wrong. Now, what does that mean? Are you looking for a crack in a piece of metal? Are you looking... How are you going to know if something's gone wrong?
Essentially, yeah. You go to the maintenance manual, and it will tell you what to inspect. Boeing have already done all this work and said, in this situation, these are the components that are going to fail, that might have issues. And so the maintenance manual states, go look at them, and if you find anything wrong with them visually, then you may need to take them apart and to figure out exactly what needs replacing. And all those parts will then go back to manufacturer, who will do what they need to do with them to get them back to be serviceable again. All this stuff is all laid down for you. There's very little you have to actually sit and think about. It's all laid down because it's that important. And Boeing have already done all this work in computers and probably on actual aircraft as well to figure out what you need to look at depending on what the pilot's done to it.
That's good that it's so well engineering-wise controlled like that. You've got specific metrics to work to.
You must have limits. You must have limits for these things. It's basically a go or a no-go for them. It's not to say, well, have a look at it, see what you think.
That's what I was thinking. Where's the metric in there? How do you, is that good, or is, so, okay, very good, very good. Damn, I did have a really good question lined up and I've forgotten. So we'll just go. Oh yes, just about, and I won't spend much time because we've talked about this before. I just found it fascinating in DCS. They've modelled airframe fatigue, for a better word, for the F-14. Every time you jump in an F-14 in DCS, you get a random amount of fatigue points, for lack of a better word. And that's not necessarily the hours, because you could have, as you'd agree, an F-14 that had flown, I don't know, how many, 10,000 hours or 40,000 hours, however long is long, and it had almost no G on it because it was a show vehicle or something, and it hadn't been used in combat, and have very little wear on it. And then another one which had much less hours on it, but the pilot had put it through many G cycles, and the airframe would actually be in worse condition. And that's kind of simulated in DCS. So you get a random, you spawn in, you get a random amount of fatigue, however it's measured, and you can go and snap your wings off much easier than if you respawned in another one and you've got much more or less fatigue points. I just found that a fascinating thing that must be real, right? In things.
I suppose to an extent. I mean, you'd be a bit annoyed if you got in your aircraft and it suddenly reset to a random amount of fatigue.
Yes,
it sounds like me in the morning sometimes, but no, it's exactly how fatigue affects each individual. I mean, even between individual airframes. Because it's been put together by someone different riveted this panel on, and it on that day in the Boeing factory, so it might be slightly more susceptible than another one. But this is why we do like regular maintenance inspections and in-depth inspections, including like X-ray and stuff like that.
Roger. Okay, right. In Civvy Street, our little Cessna's engine or Rotax engines go to about 2,000 hours time between overhaul. How is that compared to engines you work on? Is the TBO more or less, say, on a Nimrod versus a Comet, or a C-17 versus a comparable civilian airline jet in peacetime conditions? You may need to explain the question a little bit and then your answer, please.
Yeah, so essentially engines have got a life based in, measured in hours, airframe hours, and various things will have to happen at certain points in that life, but eventually it gets to an overhaul state and you've got to take it out, send it back to manufacturer where they strip it down, inspect it, put it back together, and then you get a shiny new engine back. And yes, between aircraft, different engines, that will vary. I can't off the top of my head remember any numbers for them. 2000. That sounds not completely out of possibility for something like a Chinook, but generally, I've found that engines tend to be replaced for other reasons before they get to that level of flying hours. So for usually FOD damage is one of them. On a helicopters can be more susceptible to over temperatures of the turbine when you pull like lots of maneuvers, or it has an additional problem somewhere like in the fuel scheduling. So the engine overheats, and because it's gone past a certain temperature, that means essentially you just go to the book. It's got to this temperature. Yeah, send it back. Take it off. Send it back to manufacturer because they've got to do some work on it to get it back to being serviceable. And usually these sort of engine changes, if it is coming up to overhaul time, it'll be scheduled in to the next depth maintenance. So because you've got the aircraft there anyway, and say when our aircraft RAF ones used to go to major, where like every 5-6 years, something like that, where they get properly stripped down, the engines come out anyway. So if it was within a couple of 100 hours of overhaul, you just send it back anyway and fit a new one. There's no point in fitting the old one back in and then 200 hours later take the engine out and then replace it. So a lot of these things are scheduled in with depth maintenance, and people with the appropriate authority have the power to extend these if possible or if required. So give it a 2% extension on that life to get it to that depth maintenance, because it makes your life easier. But that's down to people with the appropriate authorizations who are higher up than me. Quite a bit higher up than me, like most people are. But that's there's a lot of play in the system anyway. But yeah, something like a 2,000 hours, I think probably sounds about right for a Chinook type engine. But airliner ones usually go on a lot longer than that, because you don't want to be sat on the ground replacing engines all the time. Because when an airliner isn't flying, it isn't making money.
Any idea what kind of factor of safety is built into these kind of... Well, exactly the kind of thing we're talking about. If it's 2,000 hours, TBO, any idea what kind of factor of safety? I mean, is it expected to run to 4,000 hours, or is it expected to run to 6,000 hours?
I think it's difficult to say, because normally these things are based around an individual component inside the engine, as opposed to the engine as a whole. It's a case of, this turbine disc inside it has got a life of X number of hours. The rest of it might be okay, but this one in particular has got a life to that, so it has to be changed, because we can't change turbine discs. You just change the engine, and it's a manufacturer job to go and change that sort of thing. So usually they're lifed on components inside the engine, which won't be able to be replaced at first line, more than necessarily the engine, the entire engine itself. It's just that it's a lot quicker to take one off and put a new one on than take it off, strip it down, put it together, do all your testing on it, and then put it back on the wing. It's the difference between first line maintenance and depth maintenance, like component overhaul and stuff.
Okay, well, let's move on. This is interesting. What's the weirdest or funniest thing that you've discovered while doing maintenance? I bet there's some crazy stuff that's got sucked in weird places.
Yeah, birds' nests are a common one, especially on large aircraft, because they like to make their nests in these nice sheltered places where there are also engines, or in flying controls, that sort of thing. You can find some aircraft have specific birds' nest checks before flight, because it's not the first time I've done it at Brontingthorpe, but as well, where you drop a panel and a nest falls out, complete with eggs, which then smash all over the floor. And especially on Tristar, you'd have, because you have passengers a lot of the time, mainly Army, more than one adult magazine, shall we say, has been found stuffed down the back of a seat.
That's funny.
Even like mobile phones and stuff, you can find that sometimes in weird ass places. That was the I had to think about that one a lot, but I cannot remember anything like utterly ridiculous off the top of my head, apart from them. But yeah,
Roger.
That was as far as I got with that one.
Just reading it, ITO did bore scope inspections. Are they done by maintainers like you, or is that level done by the company, by the manufacturer?
I don't know. I've done borescope inspections because they are, you get basically cameras stick inside the engine, and those access holes are specific for looking at certain stages of the turbine or whatever, because you're just doing an inspection of it. You're not replacing or anything. So that yeah, those are first line jobs, boroscope inspections.
Right, okay, makes sense. Okay, which bases / airfield were you stationed at?
So when you first join up, you go to RAF Halton in Buckinghamshire. You do your basic training there, which teaches you how to be some sort of a military type person. And then after that, everyone goes out to their individual trade training as a engineer. Mine was at Cosford, where the museum is, which we definitely have to go to when all this pandemic stuff is over. And spent like 14 months there, did on the trade training there. And then my first posting was to Kinloss in the northeast on Nimrod, which was pretty much where I grew up anyway. So far north of Scotland, did 7.5 years there, went down to Bryce Norton in Oxfordshire, with the transport fleet, and then went to Odium on Chinook, and I'm now at Waddington in Lincolnshire, but I'm down this end of the neck of the woods near Kemble doing my licence course. So yeah, I've been all over the place, but it's the main thing I haven't worked on is fast jet because it doesn't particularly appeal to me.
Roger. Okay.
And I've been lucky in that, apart from Chinook, I've basically been able to go where I wanted to. Chinook wasn't where I wanted to go, but when you get promoted, depending on how far down the promotion list you are, depends on if you get what you want, because it's first come, first serve. And none of the places I wanted to go were available by the time they got to me. So I was kind of like, this is where we're sending you. And that's part of just military life, grin and bear it, or leave, essentially. So I grinned and bear it, and yeah, it was fine in the end.
Cool. What skills have you personally gained for civilian life from your RAF career? Interesting.
Essentially, as I mentioned earlier, when I first attempted to join up as everyone, I thought, this was me. Why wouldn't they want me? I got a bit of a sense of humility out of that, and did a lot of growing up, I feel. A lot of people go to university, do that sort of thing. I ended up joining the military. And yeah, you do a lot of growing up, and interpersonal skills. There's a classic one, because you get to deal with all sorts of people, including foreign people as well. And definitely around the world, foreign militaries have got if you are in the military in your country and you find someone in another country in the military, you definitely have that. Yeah. There's just some sort of connection.
Everyone
there,
says that.
Yeah. And yeah, it's been great. I mean, I've also got a lot of leadership training, if you like, which I definitely didn't have when I joined up, and it's definitely something that you improve on, because you're thrust into those situations where you need it, and if you don't have it, then you're screwed, essentially. Yeah. So that's all part of the military side of things. So it's not even about like qualifications or anything. It's just personal development almost. So yeah, it's I wouldn't change it at this point.
Very good. Which aircraft required the most man hours to maintain, and which one did you hate and love working the most? We've kind of answered to that, but anything you want to add to that?
No, I think we pretty much covered it earlier on. I would definitely say Chinook. The C-17 wasn't great fun to work on because it was designed more for Americans. Who have a lot more manpower than we do and a lot more aircraft. We only have 8. They have about 250. And so we absolutely fly the tits off us. Yeah. All of our aircraft are the fleet leaders of the C-17s around the world. We're getting on towards the fatigue life of one of them. Wow. The first one we had, because we got it, and then we just flew them to Afghan and back constantly for 2 decades. And so there's a lot of hard work goes on, and it needs a lot of people to be able to do it. We just don't have the same amount of manpower as the Americans do. And so yeah, it was hard work in that way. But it's not something I massively enjoyed at that point.
Okay. On to the psychological questions. How does it feel to work with aircraft all your career but not get to pilot them?
There is a little bit there which suggests that would you want to
I thought that.
pilot an aircraft you fixed? It's one of those engineering standards questions or quotes that they put up on a poster. It's just like, would you fly on an aircraft you fixed? Half the time you turn around and go, oh God, no, definitely not. But it's I enjoy having a play around with it, especially in the simulators. When you're doing your Q courses to qualify for that particular aircraft type, and you regularly go into the simulator to try out all the systems to prove that you understand them and to learn from them. That's about the closest you get to it, and that part's enjoyable. I think the best part is watching it take off. If you've been attempting to fix something for ages and you finally see it actually take off because you've managed to fix it, that you get quite a, well, I do anyway, but I may be weird, that you get quite a buzz from that. It's not necessarily wanting to go and pilot the thing, but actually seeing it fly and seeing something working after you've managed to fix it is quite enjoyable.
Roger. Not quite the same.
But then, as I say, I might be a bit strange. So there we go.
We like, well, yeah, that's why you fit in. I've been working on a 3-decade-year-old car for the last 6 months, and I've overhauled pretty much everything that's overhaulable. And today I drove it for the first time on the road to take it for its MOT check, and I was terrified. I couldn't go above about 20 miles an hour, and I'd had no trust in my mechanics at all. But we made it there, we got MOT, and we've made it back. So, yeah, can't be that bad. I know what you mean. It's like... not really a question, more of a statement. I was a British soldier between 1990 and 2002. If it wasn't for the Chinook and its entire crew outside of Sarajevo in 1996, I wouldn't be here today. What stories do you have about your time in the service from the soldiers? And thank you for your dedication to service. Question from Marcus on Discord. Do you have any? Because you weren't. Did you? Oh, okay. What's your answer?
So especially in the Chinook world, you do a lot of work with Army and Navy, mainly because things like the Commando Helicopter Force is basically tri-service, and you also have the Joint Helicopter Force, which again is tri-service, and it's so you do end up working with a lot of other Army and Navy guys, and I find a lot of Navy pilots, especially like Tim Davies did, they transfer to the Air Force because we've got more planes than they do, and so they get to do more flying. But yeah, it's when I was on Tristar, because you were doing the Afghan runs, you were taking the troops out, bringing them back constantly. You had a lot of interaction with them, but not the sort of interaction that you'd necessarily expect. So because I was ground crew, when you were flying with it, you got a seat, a row of 3 to yourself at the front of the aircraft, which was nice because you're doing a fair amount of work, so it's nice to have that space to yourself. Whereas all the Army are basically shoved in down the back, unless they were VIPs, like higher rankers, generals, that sort of thing. In which case they were at the front of the aircraft as well, but not necessarily with their own bank of 3. And it wouldn't be the first time that a general has said, "Hang on, why am I sharing this bank of 3 with 2 other people when this guy here with no rank whatsoever is sat at the front by himself?" At which point he gets told to bind his neck in by the crew, because I'm an engineer, he's part of the crew, go and sit down. So and there's definitely that disconnect between the services where a lot of the Army don't understand us, we don't understand them, but it does make for some fun interactions. But yeah, the Chinooks have been involved in all sorts of stuff over the years, and there are things I've been involved in. Engineering wise, we don't necessarily get out into the field to see the immediate reaction of it all, but you do see them like when they come back from these sort of things, and that was one of the most enjoyable parts of Chinook, like knowing that I was involved in a way with that sort of thing, and you are actually doing something worthwhile, something important, and you can see that the higher ups, if you like, even the Army ones, are appreciative of the work that goes into it.
Roger, very good.
So yeah, cheers to Marcus for what he's done as well, because he's clearly been in the thick of it.
Okay, we'll tie the next 2 questions up as one. What was the best thing you can remember about the Nimrod, and what would you say is the worst job or repair you've done on the Nimrod?
So 13 and 14, we'll shove them over to the Nimrod side on the right-hand side.
Have I skipped?
Yeah.
Stand by.
If we
Yes, you're right. Scratch that.
Yeah.
Let's move on to 15. We're going to go in a funny order.
Yeah.
We've got Martin's engineer's efficiency kicking in, so we're going to skip questions. 15. How different is age-related fatigue on airframes of planes and helicopters? Did they age the same, or it's a different pattern for both types? That's an interesting question.
Yeah, so it's a large aircraft like Tristar airliner. Ages a lot differently to something like a fast jet or a helicopter, where they're on like constant G's. You know, a Tornado might have been scrapped at maybe sort of 8,000 hours flying hours. We had Tristars that come from Pan Am and were then flying with us. That were still when we got rid of them, were still flying, had 50,000 hours on them because they're in a completely different environment, a completely different situation, and that's how. I think we discussed this in the last video, where they are judged on their cycles of pressurization and not necessarily flight hours. So the aircraft, its entire life may have X number of cycles on it, but the flying hours we don't really care about. You do your maintenance according to your flight hours, but so you can plan it all in. But the actual fatigue life of the airframe is more based around the pressurization cycles, because that is what literally puts the pressure on it. Having that pressure on the inside, nothing on the inside, that differential is what gives you the, if you like, the life of the aircraft. Whereas with your fast jets and your helicopters, it's literally based around the G loading that you're pulling, and they will accumulate that a lot faster than an airliner will. But each individual aircraft type will be different based on what the manufacturer decides. So that they will test this. They will put airframes through static loading as part of the development to see what fails first. That's one of the improvements with the Mark 6 Chinook, the F model that we have, where it has from manufacture a massive strengthening plate over the cockpit, which was added to the earlier models based on computer simulations they did, which showed that this was the weakest part of the aircraft and most likely to crack. So there's a massive strengthening plate on it, and what that achieves is it moves the cracks elsewhere into the aircraft, so you don't have to go and find them. There is always something that is going to give, like the weakest point of the airframe, and we just leave that to Boeing to try and figure out and what to do with it. And during all our inspections, you're just looking for cracks, because that's just what helicopters do. It's a fact.
Okay. Where are we? What was your first job you actually did on an airframe, if you can remember?
Yeah, so my first night shift on Nimrod, straight out of training, I wire locked a pipe.
Oh, how about that?
Right, so is wire locking something you're familiar with?
Well, can you just explain it? Because obviously on a car you don't wire lock anything. You just turn the bolt to a certain torque and it's expected to stay. But you have redundancy in an airframe. If you can go over that, please.
Yeah, so wire locking is basically a way of mechanically securing or mechanically locking a pipe or a fastener, just about anything really. But we'll stick with pipes to make it easier. So if you imagine you've got your pipe with a union on it that's connecting onto another union, you don't want that pipe to come loose through vibration or whatever. So on the flat of that union, you drill a hole through that. And then you take a piece of wire. It looks like solder wire, but don't use solder. I've seen people do it. It doesn't react very well to it. You put it through it, and then you attach a pair of pliers. You fold it back over itself, so you've got two strands. And then you attach a pair of pliers to it, and then you twist it. And you twist it in the direction that that union tightens. And then you basically take that wire around, you attach it to another locking point. Could be another pipe, could just be a locking point on fuselage or a hole that's been drilled somewhere. And then you put one strand through that hole, another one around the outside, lock it again on the outside or on the other side of that, give it a quick pigtail, and that is now mechanically locked using the wire, so that if the union tries to undo, it just pulls on the wire and can't move anymore. That is a basic locking technique for many, many things. Pipes, pipe unions, flying control rods, all sorts of things. You can wire lock them. It's basically a way of trying to stop things coming undone in flight through vibration, or that sort of idea. And that was the very first job I did.
Are they still wire locking on the contemporary airframes? I guess they are, aren't they?
Yeah, certain things are. Certain things that you don't want to come undone by any means. It's getting less and less. On Nimrod, literally everything is wire locked, which is an absolute ball ache. But every single pipe unit, whatever. When I got to Tristar, I was looking around, and very little is wire locked. But when you get into important systems like, brakes, brake bleeding unions, things like that, a bit more common on those sort of things, but not on every single pipe as Nimrod was. I think it was more of a British thing, to be honest, because I believe VC10's about the same. But it's quite a common thing for on the flying control side of things, especially on Chinook. There's a lot of wire locking going on there because of the amount of rotational energy involved or whatever, and the vibration. It's a lot more susceptible to it, so a lot of things get wire locked. And it's one of those basic skills that you basically have to pick up quite quickly, but you will, if you stay first line, you will get used to it. And it's also one of the harder things to do when you're trying to wire lock something you can't see. You can either get your head in to look at, or you can get your hands in. You can't get both. Or using a mirror with a torch, to try and see what's going on. And there are definitely some jobs where you take a much lower standard of wire locking than you would in a job which was right in front of you, simply because you can't see it, you can't get to it, but you still have to wire lock it. So that's one of those situations where the manufacturer has made this and then built the aircraft around it, but somehow you're expected to wire lock it.
Roger. Okay, we're next going to jump on to some aircraft-specific questions, and then we'll come back to the more general questions if we get time. We're going to jump, first of all, if it's okay with you, to the mighty Nimrod. And we're going to jump to question 1314. What is the best thing you will remember about the Nimrod?
I just like that because it was my first posting. It's a very mechanically based aircraft. So it's not, fly-by-wire. It's not, computer-driven or whatever. Everything is pulleys, cables, simple hydraulics. It's quite an agricultural Heath Robinson type affair. And so, as an airframe guy, that as my first posting was really good because it basically carried on teaching me, especially with the hand skills and just the way mechanical things worked. And it was really loud as well. So that part of it I really enjoyed and was a good sort of lead into my career. So if I'd gone straight onto something like a Typhoon where it's all fly-by-wire and all computer-based and everything, I wouldn't necessarily have enjoyed it as much, I don't think.
Roger. Okay, good answer. What was your worst job or repair that you had to do on the Nimrod?
High-pressure air valves.
What's that?
So these are a couple of valves. There's 2 per engine, and they are basically valves allow HP air to the engine for starting and take HP air, high-pressure air, from the engine for use in conditioning and pressurization and starting other engines. And they were an issue because the conditioning systems in general existed in a very they were all on the rib 2, so the rib that goes between the 2 engines. The engines are on the inboard of the wing, and the rib that goes between the 2 engines, all the conditioning stuff was sat on there. So they were a pain to get to in the first place. And generally, when you undid one clamp on it, the one part of it would spring away, and it was under quite a bit of tension in general. So getting a new one to fit in there was just a pain in the ass. And if you had to change the other one, then you just took the engine out to get to it. That was the only way of doing it. They're basically just cable controlled from the flight deck, and it was just a pain to do. I don't know exactly what about it made everything about them so difficult, but it was just one of the jobs I never wanted to do ever because it was just so much work. So we'll leave that one there. I think that'll do for that one.
Okay. On to question 24. Was the Nimrod's oxygen supplied from internal tanks you have to fill up prior to flight? What about the rest of the airframes you worked on?
So Nimrod had a liquid oxygen tank down the back, 25-litre lock spot, which was filled up prior to every flight. And that was basically the crew's emergency oxygen. So it would only be used in event of depressurization or hangovers. But usually all the your cabin conditioning is just done from engine compressed air. After it goes through the compressor, before it gets to the combustion chamber, you take off that high pressure air, and then that is then cooled and pressure adjusted as required, and then fed into the cabin to pressurize it, cool it, and give fresh air. And there's no recycling going on. That air then goes in and comes out of a depressurization valve, which is the adjustment for how pressured you want your aircraft to be. So if you want to raise the pressure inside it, you close it off. If you want to dump all the pressure inside it, you just open it up fully. But there's no recycling of air going on at that point. But your liquid oxygen, was just a backup in case of emergency. And if you were going on detachment, you had the ability to fit a second pot to it. So you had 50 litres, because liquid oxygen isn't always easy to come by, depending on where you're going. And also because you had more crew on board, because you generally had us going with it, so you carried 2 pots of it. Although annoyingly, you could only fill 1 pot through the aircraft fill point. The second pot, you either had to swap them over, or you had to take it off the aircraft and fill it off aircraft, which is just one of those really annoying design features, which would have been so much really easy to fix in design if they'd actually thought about it. But there we go. That's just me harping on about aircraft designers again. Tristar, again, your normal cabin conditioning system is all from the engines. The crew had a gaseous oxygen bottle, like a massive green oxygen bottle on the flight deck, which you could use in the event of emergency. So this is just high pressure gas oxygen, not liquid oxygen. But in the event of emergency down the back end, if you're a passenger, when your oxygen mask falls down and you put it on, what you were setting off there was the chemical reaction. So it's not liquid oxygen, it's not gaseous. It comes from I want to say a permanganate solution. I can't remember now. Basically, there's a solid which, when you set it off, it generates oxygen, and it basically just decomposes into oxygen and another solid, and it gives off that oxygen as gas, which you can then breathe, and it lasts for X amount of time. I can't remember off the top of my head, but each bank of 3 seats would have one of these up in the up above it in the back where the drop down for your luggage would go, and it was up in there, and where your oxygen mask would come down from, and that's where you got your oxygen as a passenger. Interesting.
I was unaware of that.
Yeah, I couldn't tell you offhand, but I think most aircraft now have got onboard oxygen generating systems, which are basically a molecular filter that takes air, filters out the nitrogen, so all you're left with is oxygen, and that's how modern aircraft do it. I think
that's going to be my exact question. I mean, are we talking about just normal aircraft pressurization and environment? Is that done? That doesn't come off the engine anymore, then, does it, or did it?
It will do, yes. It's on most aircraft, because it's an easy supply of air you can get. Something like 787, it may be slightly different, because that's all like electrical based, but I'm not going to talk about that. So even C-17, the most modern thing I've worked on, is all pressurized from the engines. But again, it has an onboard oxygen generation system for.
Is it for the emergency?
In fact, no. Let me think. Hang on a second. It had a nitrogen generation system for the fuel tanks, to inert the fuel tanks after they were empty. It also had lock spots on boards for liquid oxygen for the crew, but it also has lots of small oxygen bottles you can walk around with in the event of emergency. And Chinook had nothing, to be honest. It could carry personal oxygen bottles for the crew if they're going above 10,000 feet, but it's one of the joys of flying in an unpressurized low-level helicopter, is you don't need anything like that.
Yeah, sure. Okay, fine. Right, then we're going to jump to question 28, I think is next. 28. What are your thoughts when you switched from the Nimrod to the C-17? Any better or not?
So I went from Nimrod to Tristar to C-17, and it was a very interesting way of doing things, because you got to see something which was 1950s, gone to 1970s, and then to like 1990s technology. Doing it in that order, as opposed to new people who'd gone from like a very modern aircraft like the Sentinel and had gone to like Tristar, and for them it's like generations backwards, like the steam-driven gauges. So to me, Tristar was a step ahead.
You got to visualize the natural evolution then.
Yeah, pretty much. Everything from being steam-driven and cable-driven gauges and everything to something that was more computer influenced, if you like, in the TriStar than something that was basically computer-driven, like a C-17. It's interesting how things vary, but it takes a while to get used to. I spend the first 6 months on TriStar pining for a Nimrod because that's what I know. I don't understand the C-17, the TriStar as such. So I want to go back to where I used to work because I understood that. But it's like everything. After a while, you get used to it, and it becomes more enjoyable. It's just anything. It's like anything. When it changes, I don't like this. I don't like change. I want to go back to what I know. But you get over that eventually.
Question 42. What was stored inside the Nimrod's bomb bay? I remember talking about this when we were together. Was it flying with bombs while on a mission or else?
So, depending on what you wanted it to do, depending on what it carried in there, generally, day-to-day life, it had a life raft in the bomb bay, like a survival thing that you could drop to a ship in distress, or you drop if you were going to ditch into the sea or whatever. It had a survival kit in there, quite a beefy one. You could also, there's a list on Wikipedia of all the stuff it can carry, but it goes anywhere from like harpoon missiles, anti-ship missiles, flares for marking positions of submarines, torpedoes for taking out submarines, all the way up to they did trial it with free-fall bombs at one point, 500-pound bombs, and the ultimate weapon, a nuclear depth charge. I mean,
that's
you
so
appreciate
50s.
how much.
That's so 50s.
You can appreciate how susceptible submarines are to normal bombs because of the way water reacts to pressure, and overpressure waves and stuff. You just multiply that for a nuclear depth charge, and it's a bit of a beast.
All of the fish die.
All of the all of the submarines. So it just starts floating to the surface. So yeah, you could carry an awful lot in there. If it also had an ability to carry extra fuel tanks in there. Which I don't think was ever really used, to the best of my knowledge. It had you could put baggage containers in there if you were going on detachment to stick barbecues in afterwards, whatever, that sort of thing. And I've even seen a couple of jet pipes go in there because an aircraft had an incident, and the quickest way to solve it was basically just fly up 2 new jet pipes and just shove them in the bomb bay to do it. It was quite useful, but it's surprisingly small if you have to be in there and the doors were closed.
Yeah, it's very shallow. I found it very shallow. Is that just me?
No, it definitely was when the doors were closed. There's not as much space as you think there would be, but yeah.
Okay, excuse me. Okay, that's the Nimrod done. Moving on to the TriStar, question 25. The TriStar looks such a good tanker. Was it its age or range that finally ended the fleet's service life?
Effectively, it's almost its age. The airframes, as I understand them, had plenty of life left in them, but the Air Force wanted to replace it and the VC-10 with a newer tanker, in this case the Voyager, the A330, which is a good aircraft, but at the end of the day, the aircraft only have a certain life and they also need support. And we had 8 TriStars flying, and there was maybe one other flying in the world, and no company really wants to support that. So yeah, it gets to a point where you just say, yeah, we need to replace it because people are going to be, we're spending a fortune keeping this thing in the air, because Rolls-Royce will be charging us a fortune to maintain these engines, for example, and their maintenance line is only being kept open for us, so it costs them a lot of money. So. You have to look at the support aspect of it and getting spares, especially when you have the only fleet of these aircraft in the world. Spares are somewhat difficult to come by at that point because no one's making them, no one wants to maintain them. The actual range of the aircraft, the amount of fuel it could get rid of, and everything was not an issue. We're still flying to the Falklands quite happily and trailing aircraft down there. It could carry an absolute boatload of fuel. Which I think is pretty much the next question.
Anyway. So that's just reading. Yeah, when a tanker is flying, is it consuming fuel from its own tanks or from the fuel loaded on board as a whole? If so, does it mean it would have unlimited loiter time in the air?
So the TriStar operated on a fuel system which is basically known as a fully integrated fuel system. So you could basically move the fuel around from anywhere to anywhere. The Tristar had extra tanks. The tankers had extra tanks fitted to them in what would have been the baggage compartments. Basically, you look in there and there's fuel tanks which look exactly the same shape as a baggage container. And they added about 40 tons extra, I think, something like that, roughly, to its total fuel load. So your maximum fuel load possible was about 140 tons, which is a lot. Now, you could fill that fully up, go take off, and go and loiter, and give none of it away and burn it all. It would probably take you maybe 20 odd hours, maybe something like that. You'd be up there for a long time, but you're not achieving anything.
Does that, sorry.
Yeah, carry on.
Does that mean if let's say you're refueling someone, does that guy who's being refueled, can we essentially drain the Tristar's internal tanks as well as the baggage compartment tanks?
You could, yes. You could pump your fuel around. It could only be given out from the rear baggage compartment fuel tank. That's where the pumps were to send it to the hose drum units. But you could transfer fuel around from anywhere to anywhere with opening up the right pump, opening up the right valves, and sticking the right pumps on. That's not an issue. And it's down at that point to the flight engineer to basically make sure that where you're sticking the fuel is balanced for the aircraft.
Oh, yeah, that's a good point, because that's a big weight, right?
Yeah, so you would, although obviously Lockheed worked it out when they built the thing, where the fuel would go in the order it would be drained in for the engines. When you add these extra fuel tanks, that changes everything completely. So, if you say, like, we want 20 tons of fuel in the refueling tanks to give away, the aircrew would specify where they wanted it, 14 tons in one and 6 in the other, depending on the center of gravity. And that's all sort of thing they dealt with. They told us what they wanted and where they wanted it. We would put it in, but it's up to them to work out all these calculations, because that's what loadmasters do. So in theory, yes, you could give it all away, and it would be the first time a tanker has stayed on task longer than it was planned to and given away more fuel than they had planned to help someone out who was in trouble from another air force or the Falklands, the Black Belt 1 mission is a prime example, where they gave away more fuel than they could.
And they came very close, didn't they?
Yes, to the fact that they knew they couldn't get back to Ascension if they didn't get another tanker, and they couldn't radio back to get us another tanker. But that's another story.
Roger. I'd love to cover. We've done a kind of cheap covering of one, but I'd love to do a proper coverage of that mission at some point. But anyway, another day. The Tristar. Yeah. How do you extract the middle engine from the Tristar aircraft, and do you need to somehow clean the internal tank from algae and rust? I don't really understand what he's getting at, but okay. How do you make that?
So the center engine. I am just sending you a picture as we speak. The center engine is a bit of a ball ache to remove. It requires...
Wow, yeah.
Yeah, it's quite high up. You can't really appreciate it from that picture, until you actually get up close and see how far high up it is. But essentially, there's those holes just above in the structure. There's a load of beams that fit in there, and to those beams, as they come out, there's you attach gauges and chains which hang down to the bottom, and then you attach these chains to an engine cradle, and then you hoist the cradle up to the engine, disconnect all the engine mounting points and all the connection points, and then you lower the cradle down on the chains. It's not a quick job at all. There's a lot can go wrong with that, but that's how you do it. It's one of these things that separated this from the DC-10, whereas this is a bit more complex. The DC-10 is probably a bit easier because it's all out in the open. But yeah, that's how you do it. And the engine itself was exactly the same as the wing engine.
Well, sure. So when you're disconnecting the engine mounting points, where are you? Positioned? Where's your body? I can't picture how this works.
At this point, there would be a load of gantries, etc., around that part of the engine,
like scaffolding,
and you'd be standing on that, and you would be in there with your torque wrenches into where those access panels are, in there with your massively long torque wrenches, attempting to do these bolts, and hoping that when you undo these bolts, the whole thing doesn't just fall out.
All right, yeah.
So that's how you do that.
Right, very interesting. Okay.
As for the fuel tanks and algae and stuff, generally it's not an issue because the aircraft is stored with fuel in them, and because as long as they're operated regularly, fuel sits at the bottom of the tank and gets mixed up with the fuel and burnt. You can do that with water. You can't burn pure water, but if you mix it up with the fuel through the fuel pumps, it emulsifies, and you can quite happily burn that in the engines. They don't mind. And generally algae will form at the water and fuel interface. It's something that everyone remembers from their training, basically the name of this algae that forms, that basically eats fuel, lives in the water, and the stuff it shits out is the stuff that's really bad for the tank and causes corrosion. But generally there's enough fuel going into the tank and then coming out quick enough that it doesn't become a problem. And if aircraft are going into like depth maintenance for a long time, then the tanks are drained, vented, cleaned out, etc. So it's generally not a problem, not anything we have to worry about.
Roger. Interestingly, I've just taken apart a 26-year-old gasoline tank, fuel tank, and I really expected it to be in bad condition, but inside it was as new, immaculate. I really didn't think, because it's not, it's not kept pressurized particularly, it's not kept well looked after in any way. Moisture can get in there, but it was absolutely immaculate. I was just found that interesting. But anyway,
that's Japanese engineering, mate.
That's Japanese engineering. There we go. Right, let's push on. We're on 29. Wow. Do you cool down the fuel load? How do you fuel?
It's very excitable there, isn't it?
How do you cool down the fuel load on the tanker? I don't understand that, but you'll explain that in a minute. Must be expanding and collapsing a lot if you fly over the North Sea over Iraq. What's he getting at here?
So essentially, yes, as temperature changes, fuel expands and contracts. It does it on your car. When you if you fill it up when it's cold, you get more fuel for your money because it's denser, because it works on the counter works on volume. And if the fuel is colder, it's denser, so you get more fuel for the same amount of volume.
Does that mean
you get more fuel for your money?
Does that mean if you had a way of cooling down your fuel pre-combustion, you could make it more power? Have I got that completely wrong? Per fuel? No, not really.
To be fair,
because fuel is not your limiting factor.
No, on aircraft it's not a massive thing. You do because generally when you're flying, fuel cools down. So you once you take off, you get to say 30,000 feet, and up there the temperature's like minus 30 wherever you go. It doesn't matter if you're over the North Sea, over Antarctica, over Iraq, over the Middle East, whatever. The temperature up there is pretty much constant. So it's always, for instance, say minus 30. If you're up there long enough, your fuel will cool down and your fuel will go to about minus 30. It's cold soaked. And at that point, if anything, you want to heat it up a bit to help atomize it as you put it in the engine. And because you have things in the engine that you want to try and keep cool, you can use that. And you pass through what's known as a fuel-cooled oil cooler. It's basically a massive matrix that the engine oil goes through, and the fuel coming in, because it's really cold, you can use it to help cool the fuel, cool the oil. You can also call it an oil-heated fuel heater if you really want it. Either way, when you then land, that fuel takes a long time to heat up again, and you can quite frankly, if you walk underneath an aircraft after it's been cold soaked like that, and you've landed in somewhere reasonably humid, you can see about a layer of like ice and frost forms underneath it and then melts again as it all warms up. So even if you're out in the Middle East, when you load an aircraft with fuel, the fuel may have been sat around in a tanker in the middle of the midday sun, in the middle of the desert, for several hours, for like a few days or whatever. It will be really, really warm. So you load it onto the aircraft, and then all it's going to do after that is cool down, so it just contracts. But you do have to take account of that when you are working out basically how much fuel has gone on, because again, it's down to the density and the volume it takes up, and that's called your specific gravity, where your fuel volume varies depending on the weight. The Bowser driver is only interested in giving you a volume of fuel, but you want to know how much it weighs, and basically through that calculation you take into account the specific gravity. It's about 0.8 for aviation fuel, and that actually varies depending on the temperature of the fuel. So you have to take that into account. But the actual fuel expanding and contracting in the aircraft is not really an issue unless you basically fill it up when it's cold with cold fuel to the maximum the tank can take, and then leave it in the middle of the midday sun, which is not something that's really going to happen. but Nimrod was quite prone to it, where the fuel would expand during the day, and it would come out of the vent system, and you basically had pipes and drums sat underneath the vents to take account for that. But if you're really good, you just basically left the top off the fuel tank when you were refueling it, so that it had a bit of space to expand if it had to. But generally, it's not something you need to worry about, because up there the temperature is the same wherever you go.
That's very interesting. All of that is new to me, which is very exciting. So I think the main thing that I found interesting is that you have a kind of dual cooler, or I don't know, but you had, so the fuel before it goes into the engine is going to come in at minus 30 degrees ish, and then you're going to run it through a heat exchanger with the engine oil, and it's going to have the dual effect of heating up the fuel to a more atomizable level, and the effect of cooling down the engine oil. So that's a really efficient system. One question to that: how warm would you want to heat that fuel up to pre-combustion?
Off the top of my head, I don't know.
Above
you could
minus
probably
30.
Google ideal atomization temperature for after. You could probably Google that and it would tell you. But off the top of my head, I don't know.
Roger.
I mean, it will work with any temperature, to be honest. It's just the hotter you get it, the better you get it. And it achieves, like you say, two different purposes.
Yeah, that must be the same in all similar aircraft then, because they're all going to have the same problem. How interesting.
Yeah, it was actually that is what brought down that 777, that BA 777 at Heathrow.
It got
2009.
It clogged up the pumps or something because of the ice, or
yes, so because you have water in the fuel tanks, that's normal, and at altitude it can freeze. That's normal again, and apparently it had been like particularly cold that flight, and effectively as it came in and heated up a bit, some of that ice broke free, and it came down the fuel lines, and basically sat on the end of the fuel-cooled oil cooler, because the holes in the heat exchanger were quite small comparison, and it just blocked it, because they made like a sudden demand on the throttle for some reason, and that sudden increase in fuel flow caused all the ice to come free and block on the front of the oil cooler, and at that point no fuel is getting through at all, no matter what you try. So yeah, they then had no throttle response on either side, and so they landed ahead of the runway, shall we say.
Yeah, no, that was fascinating.
But that is what blocked on in that incident. That was a fuel-cooled oil cooler. I think they basically solved it by just increasing the holes in the hole size in the heat exchanger.
Wow, how about that? Okay, very good. Learning a lot today. Jump on to 31. Did they change the landing gear of the Tristar to convert it into a tanker, or was the fuel load similar to the passenger jet takeoff weight?
No, they didn't. It's the same landing gear, etc. All you do is you change the weight of passengers, cargo, etc. that you can carry. Because yes, adding in the baggage container shaped fuel tanks and carrying that extra fuel does lower the amount of passenger and cargo you can take, but all you do is you trade one for the other. And so that if you were carrying maximum fuel load up to like 140 tons of fuel, you reduce your cargo capacity by say 40 tons or whatever, because you've got an extra 40 tons of fuel. That's the sort of idea. So no, there was no change made to it. Interestingly though, the Voyager is literally the same aircraft. There are no extra tanks on board, and it can only carry up to about 90 tons of fuel.
Oh wow!
But because the aircraft is that much more efficient, because it's only got two engines and they're much newer, it can offload a lot lot more than we could in the same scenarios.
So there's no internal tank. There's
no
extra.
There's no extra fuel tanks. No, because it doesn't need them, because it's got a much lower fuel burn. In general, you can carry enough in its normal fuel tanks to give away.
Yeah. One thing that's been bugging me a bit about the Tristar air-to-air refueling, you mentioned that all of the extra fuel that goes in, if you like, in the kind of bespoke tanks, were all at the back of the plane, where the cargo containing area was. Didn't you say that? But isn't putting all of that fuel just at the back of the plane a bad idea? Or have I missed the obvious?
It's a case of that's where the fuel tank, which feeds the hoodoos, is. All you have to do is make sure you have fuel in there to be able to give it away.
Right.
It doesn't have to be full. That's where the fuel comes from. So if you're going to give it away, you have to put it in there first. Okay. And again, that's down to the flight engineer to move it around and the loadmaster to work out what can go where. to keep your aircraft in trim.
Would that be known as kind of I can't remember the terminology, but often when I look at the fuel systems on, from a layman's point of view, whenever I learn a new plane in DCS, they've got several fuel tanks, and then they've got ones which are if you like, the pre-burn ones, pre-engine, two small ones. I think they're called feed tanks, and I've never really understood the purpose of them. That you've got these big fuel tanks, wings, back, front, all over the place. And then before you actually use that fuel into the engine, you put them through these little feed tanks, which just seems like a needless thing. Any idea about that?
I imagine it's because it's a fast jet thing, because although you have fuel pumps in your tanks to pressure feed them, you run the risk when you're flying upside down, doing G maneuvers or whatever, that you may not necessarily be able to feed the engine as much as it requires, because the gravity is fighting against where you might want to put the fuel. So by having this box, which is permanently filled with fuel, that means the engine always has a certain amount to it, regardless of what the aircraft is doing.
Right. So
that would be my guess off the top of my head. It's not something I've come across because I haven't done fast jet, but that would be my guess.
That'd be interesting. You could also manufacture that small feed tank specifically so that it was baffled, thus that you could have it work at high Gs or whatever, rather than having to engine all of the tanks. Yeah. Yeah,
it's basically a case of this is constantly full of fuel, it's pressurized, and it's constantly feeding the engine. So no matter what the aircraft is doing, the engine has got fuel and isn't going to flame out just because you're throwing it around.
Right, interesting. Okay. 41, we finished on the Tristar. How do you control the constant shifting of fuel in the tankers while in the air? And was there any structural damage you had to repair because of it? Now, that's a really interesting question. When you usually think about fuel, it's like, it's a liquid. How much damage can it do? But as you know, a liquid can do a vast amount of damage when it gets some energy in it. Any stories there?
Yeah, so when you took your fuel tank apart on your car, did it have baffles in it?
It did have baffles in it around the pump area, and I couldn't actually... I haven't figured out why, but it's obviously there for some reason.
Yeah, so in fuel tanks, this sort of size, and even in your car ones, you put baffles in there to stop the fuel moving around. So instead of having it, if you suddenly go around a corner, all of the fuel suddenly moving to the left-hand side of it, it only moves up to the baffle.
Yeah, right.
And obviously there are holes in them, so the fuel can transfer between the baffles quite happily. But by having these in place, you limit the amount of movement of fuel.
Right.
And it's the same in aircraft fuel tanks. They've got lots of baffles, which are basically the ribs, which make up the structure of the wing. Lots of holes in them, so the fuel can transfer through quite happily.
Right.
But you have these. That's how you stop the fuel from moving about. And
as a big unit,
with the volumes of fuel we're talking about, yes, it could actually, in theory, cause an issue, especially in light aircraft, where the fuel suddenly moves to the left because you're flying along. You're trying to straighten up. And then the fuel moves back to the right, and it would potentially move the aircraft back right. It's something quite light. But no, it's that's all taken care of with fuel baffles, so that you get as little movement as possible.
Roger. There's something that bugs me there that I haven't quite got my head around, but I remember seeing something about some planes have fuel bags rather than actual, like even some modern planes. I'm thinking, well, how do you baffle that? You can't.
There's probably. So Nimrod had bags in it. Tristar had bags inside the airframe, the extra tanks they fitted, and basically you just limit the size of them, so that they are small enough so that it's not an issue, and generally that's limited by the size of the bag you want to fit anyway, because fuel bags are a nightmare to deal with, like fitting them in the first place, and then basically taking them out if they start leaking. It's an absolute pain to deal with.
I saw that on a documentary one time, and when I first realised, even a big jet like you were talking about, trying to fit these horrendous bags that are going to deteriorate anyway.
So you use them as little as possible, and generally aircraft fuel tanks are structural to the wing and the centre box of the aircraft, like between the wings, and only in like additional tanks maybe would you use a bag tank. Because they're just a pain to deal with, to be honest. And like you say, to the best of my knowledge, you can't baffle them. I've never seen one that's baffled.
Yeah, how interesting. Very interesting. Okay, let's punch on to the Chinook. How does the Chinook transfer power to the front rotor blades? And if an engine goes out, can it still land on auto rotation? Interesting. So you got a whopping great drive shaft, I'm guessing. Prop shaft.
Right, so all three questions here I'm going to take together. I've been thinking about this for a while, and I've just sent you a picture.
I'm going to read. Shall I read all the questions out quickly so they know what we're talking about?
Yeah, go on then.
Next one. How different are the engines on the Chinook compared to jet plane engines? Interesting question. And 37. In the Chinook, was only one rotor tilting or both of them to induce motion? And how's it done? And now I'm going to grab your picture. Stand by. Okay, ready.
And if anyone's listening, they may want to grab a cup of tea as well. So the picture you've got on the screen now should be this is the Chinook drive system. The idea behind this is to get the two heads, the aft and the forward rotor head, spinning at a constant rate. Right? We don't fly the aircraft by changing the rotor speeds or anything like that. You don't make it go faster like that. Both rotors turn at 225 RPM, and that's what all of this is to do with. So, even the pilots don't have control of the throttles. It's not like the Huey where you've got a throttle on the collective. All that is controlled by computer, and everything is to do with the rotors being turned at 225 RPM, and everything works off that. To do that, you have your two engines, which are entirely independent of each other, and they are jet engines like normal. Are you happy, Kat, with how a jet engine works?
Yeah, I think everyone's going to be happy with that.
Cool. So, compressor, squeezes the air, add fuel, combustion, hit through the turbine, out the back, turbine drives the compressor. That's great. You can, on normal aircraft, all that force of the air coming out the back is used to push it forward. That's not what we do with the Chinook. So this engine uses what is called a free power turbine. Is that something you've come across before?
No, we've never done helicopter engine, so I'm going to start learning now.
Cool. So effectively, the engine is entirely separate from the rest of the drivetrain. It sits there quite happily, generating all this high pressure air coming out the back. What you can then do with that is you can add another turbine, which is entirely separate to the engine. So the best analogy I've ever seen of this is, a little kid's toy that you buy at the fair, which has got a little sunflower type thing on a stick. And when you blow on it, it spins. It's exactly the same idea. You have another turbine at the back of the engine, which then takes up all of that thrust that's coming out the back of it and spins up. If you then attach a shaft to that, you've now got a rotating shaft that you can do stuff with, which is not connected to the engine itself. This is what's called a free power turbine. And it's useful because if something goes wrong with either of them, the other one isn't affected. And you can control the speed of that free power turbine by varying the speed of the engine and the output of it. So all we do with a Chinook engine, and this is really common for all sorts of turbashafts and turboprops, is you take that shaft and it goes back through the core of the engine to come out the front of it. And what you have there then is a really, really compact design generating a rotational speed. This is exactly how a Hercules engine works, for example, where the propeller is driven at a constant rate. On a Hercules, if you operate the throttle, all you're doing is changing the pitch of the blade. Right? You are not altering the speed of the engine. The engine operates at whatever speed is required to keep that propeller going at whatever rate it does. And obviously, the more angle you put on the blade in a propeller, the more drag you incur, and so it starts to slow down. The engine notices that and then adds more fuel to speed up the engine to keep the propeller going at the right rate. Does that make sense?
Yep.
Cool. So what we're doing here is the same thing. So on the front of the engine, on that output shaft, we then attach a gearbox, which then turns it through 90 degrees and add another shaft, and then that goes into the center gearbox there, the combining transmission. So now we have a turbine driving the shaft, going into the combining transmission, and that transmission takes the input shaft from both gearboxes on both engines. Now, that transmission on the front of the engine also has a sprag clutch in it, the same as your bicycle has, so that when you pedal, you are providing power. If you stop pedaling, the inner part of it carries on turning. One can freewheel around the other, and you can apply power. So in that respect, you can quite easily just run off one engine because both of them are driving the combining transmission, and the one that's not running just basically it runs around on the sprag clutch. So you can fly on one engine quite happily, and they frequently do that as part of training. From that combining transmission, it takes both of that rotational input, even though they're opposite, and it sends it in one output from the front and to the back. Those are your synchronizing shafts, 7 at the front, 2 at the back. And that then rotates at some unbelievable speed. It goes at 115 times a second.
Cool.
Those sink shafts go at. Right? They go horrendously quickly, and they go out to the aft transmission and the forward transmission. Both of those then turn it through about 90 degrees and send it up to the heads and reduce the spinning, the rotational speed, down to 225 RPM. So that they are both physically connected together, and so if you move one, you move the other. And they also have to be phased together within, I think it's about a 16th of an inch at the swash plate, so that basically they're fully balanced together. And if you don't have them phased properly, then it upsets the vibration of it all so much that you can't actually tune it out using your rotor tuning, and you just have permanent vibration there. So they have to be physically connected, and they have to be phased properly for the whole thing to work. So that when people look at it when it's flying around, and you think, oh my god, the rotors are so close to turning to hitting each other. Yes, the discs do intersect, but they can't hit each other unless something goes wrong. And if that goes wrong, your day's over anyway. So it's not an issue in that point. So that's how you operate them. And again, when you put loads on the rotor disc, when you're adding power to it or whatever, all you're doing is you're changing the rotor disc, what it does to produce lift. And if that causes it to slow it down or speed up slightly, that's all sensed by the engine control systems, and then they change what they're doing to produce more or less power to keep the heads turning at 225 RPM. And that's nothing to do with the pilot. The pilot has no control over what the engines are actually doing. Its engine condition levers are either in stop when you're on the ground, in ground when they're at an idle speed, and then you put them into flight, and at that point the digital control system takes over and keeps the engine spinning at whatever speed it has to do to enable the heads to turn at 225 RPM. But the engines themselves are not physically connected to the drivetrain, and that's the whole idea behind a free power turbine that you can actually see at the back of the engine. We have rotor brakes on ours, basically a massive caliper and a carbon fiber disc brake that's attached to the sink shafts in the middle. It sits on the front of the combining transmission. And you can actually run an engine at idle with the rotor brake on, and it will stop the heads turning quite happily. And it's weird because you can see the engine running, you can see all this exhaust coming out the back, but when you look up the back of it, it's the turbine is stationary because the turbine can't turn without the drive shaft turning. The engine can, but the turbine can't.
It's a really clever piece of engineering, that is, isn't it?
Yeah, I think you'll find it's the same with pretty much anything that operates with either a turbo shaft or a turbo prop like that, where you've got the engine side of it, the gas generator side of it, and all it's doing is it's throwing all of that gas out the back onto the turbine, and the turbine is driving whatever you want it to. It's not that thrust is not like pushing the aircraft forward or anything like that. You take out as much energy as you can from that exhaust gas to drive the drive system.
Couple of questions. The main two large shafts, they've got couplings. One's got 7, one's got 2, or something similar. Yeah. What are those couplings, and why are they there?
They are just the couplings that join the shafts together. So there are from the combiner to the front transmission, there are 7 sink shafts. And in between of them, you've got a little flexi pack, which allows some sort of movement in between each one, and take up a bit of vibration. And there's 2 at the back, and those are there just to join all the sink shafts together, essentially.
Roger. So I calculated roughly that those big shafts are running at about 7,000 RPM, geared down to 225. Why is that shaft? Why is that shaft running so fast at 7,000 RPM?
Power, I presume. It's that's just you may have to speak to the aircraft designers, to be honest, but it's essentially, I'd imagine it's also to help with vibration, because the faster something's going, the less likely vibration is to affect it in that respect.
Interesting question, because I've had exactly the same with automotive. Why do the prop shaft, so the long one going down the car, always run 4 or 5 whatever times faster than the drive shaft that goes, which is basically the wheel? I
I
never
think also
got...
you can do a lot more with it if you like. You can, if something's running faster, it's got a lot more rotational energy.
That's
so you
exactly
can
what I
change
thought.
that.
That's exactly what I
You can
thought.
change that a lot easier. But I mean the speeds. I do have a picture somewhere, but I don't. It's not something I want to show unless I could find it on the internet already. But which details all the various RPMs of all the different parts of the drive systems, and like I say, the speed of like the free power turbine and the differences it goes from there to the combiner transmission and out to the other transmissions. The changes you get are quite phenomenal in speeds.
Okay.
So yeah.
And one more question. Sorry, go ahead.
Yeah, no, that's fine.
I'm just one more question that's I find interesting. The combining transmission. So we're taking two inputs or one input from the engine. Either way, we're taking those inputs, and either of them can be on or off, and we're transferring it forwards and backwards. I'm just trying to picture in my mind how close that is to a kind of rear differential on a car that works inside. I'm gonna have to go and get a cutaway section at some point.
Yeah, I mean, I suppose it's a similar sort of idea, but nothing. There's no like disconnect or anything like that inside it. It's literally basically your two inputs from either side driving a single bevel gear inside, which then goes through 90 degrees to stick it out forward and back. It's not, I say not as complex. It's not quite the same as the differential where you need to worry about things turning at different speeds.
That's what I was getting at. Yeah.
Yeah, it's not that complicated in that respect.
Right.
It's generally a much simpler idea. But and it all turns as one. So if you turn one cross shaft going into it, the other one turns as well, and it just the sprag clutch on the other side in the transmission allows it to run over without turning the engine.
Right. And the aft and the forward and the aft transmissions, they are literally just gearing it down and changing the direction.
Yes. Yeah. They have a lot of other stuff like hydraulic pumps, generators, etc. attached to them. But yes,
that's the
advantage of them because they run at a constant speed. That is what you want for your generator. It makes a generator much, much simpler because you want that to run at 400 hertz because that's what aircraft electrics operate on. Your transmission is kicking out a constant rate, so you don't need like civvy aircraft. Their engines have drive units which vary the output speed for the generator to keep it constant because the engine is constantly changing speed. So they've got a massive bit of kit in there which takes a variable speed from the engine gearbox and turns it into a constant speed when you don't need that on these because it's kicking out a constant speed anyway.
That's fascinating. Anything before we move on?
There's one last bit for the actual... Yeah, I say one last bit. I've been trying to figure out how the best way to explain this because there were questions about how you actually steer the thing. And it's quite a monster to explain, but I'll do my best. So how helicopter flight theory is a bit weird, to be honest. So your helicopter blade is essentially a wing. If you look at it from the end, it's got an aerofoil profile just like a wing. And as instead of the whole thing going through the air like a plane would, you simply start spinning it around and it will generate lift. And that is essentially how we both generate lift and steer the aircraft. So you've got your three rotor blades at the front, and what you need to do is basically imagine that as a disc, if you like. So as they're spinning around, all three blades start generating lift, and you imagine that as simply just a round disc. So if you want, you can put your hand out in front of you, and that is your disc. If you want the helicopter to go up, you simply pitch each blade slightly as you would a wing. So if you pull back on the stick in a normal plane, you change the angle of attack of the wing against the airflow, and that as you increase to a certain point, that increases lift. Change the angle of attack, it increases lift up until you get to a stall point, but we don't worry about that in helicopters. So if you want to increase lift on your helicopter blade, all you do is you change the angle of attack to the airflow as it's going through it. And by changing the pitch angle of that blade, you increase lift, and that is how the helicopter takes off. Your immediate problem you face there is that because the different parts of the blade are going at different speeds, obviously the outer part of the blade is going a lot faster than the inner part of the blade, it generates a different amount of lift. So if you look down a helicopter blade, Chinook ones especially, they're actually like curved. They've got a lot more pitch to them at the inboard end than they do at the outboard end, because you want the lift to be the same along the entire blade. So as all your blades are spinning around, they're all generating the same amount of lift. If you increase the pitch of those blades altogether, you start generating lift, and eventually that is enough lift to take the weight of the helicopter, and it takes off. And that is that's what you're doing by lifting up on the collective in your helicopter. You are changing the angle of all the blades together. If you then want to go forward, you've got to basically tilt the whole helicopter forward a bit. And in that respect, the disc, if you imagine your hand out in front of you, you are tilting the disc up a bit at the back and down a bit at the front. You are not changing the angle that's coming out of the gearbox or anything like that. You're physically changing the angle of the blades, the pitch angle of the blades, so that when the blades are around the back of the disc, they are generating more lift than they are at the front. So you generate more lift on the back end of that disc, and your helicopter tilts forward, and then you neutralize it again, and off you go, because you've now got some forward motion, and away you go. If you want to stop again, you pull back on the stick, and the blade angle changes so that when it's at the front of the disc, it generates more lift. So your helicopter tends to pitch up, and at the back of the disc, it generates less lift, so that your helicopter will literally like pitch up around the central axis. The same basically same occurs if you want to go left or right. If you tilt the stick over to the left, then you change the angle of the blades when they're on the right hand side of the helicopter, so that they generate lift on the right hand side and less lift on the left hand side. The helicopter tilts over, and there you go, you're turning left. Opposite happens if you want to go right. You generate more lift on the left hand side of the disc than you do on the right hand side. And between all of those controls, you can now get the helicopter to do pretty much anything you want by changing the lift on various parts of the disc. What you do have to remember, though, is that that disc consists of 3 blades going round and round and round and round and round. In the case of a Chinook, about 4 times a second. So if you have, let's say you keep your stick all the way over to the left, when a blade is on the right-hand side of that disc, it's pitched so that it's generating lift. By the time it gets around to the other side of the disc, you now want it to generate no lift because you're trying to turn left. So that the pitch angle of that blade has now changed to nothing. And then as it carries on back around to the right-hand side, it's now changed to generate lift again. And it is going around there, basically having its pitch angle changed like 4 times a second. And that is something that's incredibly, the forces going through it are absolutely incredible. And luckily, someone has been very nice and actually attached a GoPro to a helicopter.
That's funny.
Obviously, this is in Russia, because
yes,
why wouldn't
you
it
could
be?
only do it in Russia.
Yeah. And they've basically attached a GoPro to the top of a rotor head, and I'm just sending you a link now, which should basically demonstrate what this is like, if it decides to come up or not.
Roger. So this is must be. So is this in super slow mo then?
Yes, and you can physically see how the blade. Yeah. As the blade is going round, on one side of the aircraft, it's generating lift. It's being rotated. As it gets around to the other side of the aircraft, it's not.
Wow.
And so it goes back to neutral. Yeah. And it's doing that 4 times a second. It's going up and down, up and down, up and down, and it's having its pitch angle changed. So, the amount of force going through here is horrendous. Now, that is basically single helicopter flight theory. When you get into tandem rotor theory, right, things change a little bit. So, Chinook flight controls do not have the ability to tilt the discs forward and back. They only tilt it left and right, or fully up and fully down. And the way to basically imagine this is to put your hands out in front of you. So imagine you've got 2 rotor discs. Okay, so if you want to go up the way, you just apply lift to both of them together, and up you go. If you want to go down, you reduce the lift on both of them. If you want to tilt your helicopter forward, you apply lift to the rear disc and reduce the lift on the front one, and your helicopter tilts forward. And then you just have to neutralize that, apply a bit of collective, and off you go. You've now got some forward speed. And the opposite, if you want to pull your nose up and come to a stop, you basically increase the lift on the forward disc and reduce it on the rear, and your helicopter basically does a wheelie in midair and comes to a stop. If you want to go left, then that's about the same. You just tilt both discs up on the right and down on the left, and your helicopter will go that way. And if you want to go right, then you just apply a lift on the left-hand side of the discs, and you go right. You can also yaw them by basically taking doing the opposite on each disc. So if you want to spin the helicopter to the right, then you go up on the forward disc on the left-hand side of it, and you go up on the right-hand side of the disc on the rear one. And that differential basically just spins you around a central axis. And that is your control in a Chinook. And then the opposite happens if you want to go the other way. Basically, the discs tilt left and right in opposite directions. And through all those controls, you can now do anything you want in a Chinook. So all you need is the ability to change the angle of the blades left and right on both of them. And through all of that, using whatever combination of all of that lot you want, you can now do something like this. He copies quickly another link, which is, and I find this to be one of the more impressive parts of the Chinook display. It's what it allows you to do, and that's basically just a combination of how you use all your flying controls together. It's like if you want to get it to, instead of spinning around a central axis, if you want it to rotate around just the nose, you can operate the rudder pedals, but you can cancel out the rudder pedals by putting it with a left cyclic, and it cancels out the spinning on one head, if you like, and allows it to rotate around that instead of it revolving around the central part of the helicopter. So there's lots of things you can do there. That is, in a very, very, very brief nutshell, helicopter rotor theory and how you fly a Chinook. I don't pretend to understand it particularly well. I just know how to make it happen. So yeah, that is how you.
So
that is how you fly a helicopter.
That's very interesting. So would it be right in saying that the only, if you like, control mechanisms that we have for doing this is you can cyclic the rotors left and right, and you've got a collective on each rotor. That's the only axis of controls, and from that we can do anything.
Yeah. Yes. With the tandem rotor theory, if you want to tilt the nose forward, I stick your cyclic forward and back. All it does is it changes what the front and aft discs are doing. It increases the lift on one and decreases it on the other, and that's effectively the same effect as if you only had a single rotor head, making it lift on the front and not lift at the back of it. That's the difference between them. You can do it all with the two of them, with only the two controls.
Roger, makes sense.
There was a few other things I was going to talk about, but they've sort of dragged on with that a bit.
Okay, no, that's cool.
So yeah, that's the basics of how Chinooks fly.
That was just the right speed for my brain. It was just about catching up. Okay, that's awesome. How much time have you got? And do you want to carry on with the other normal questions, or go to viewer questions? How do you want to move on?
We can quickly go through the other ones from the spreadsheet.
Stand by. 17 here.
Just rattle through them.
Okay, so punching up back to 17. In your opinion, what makes the RAF different from other air forces around the globe? Have you noticed something that sets it apart?
We are getting smaller by the day. I can tell you that much.
Unfortunately, yeah.
And we feel massively punch above our weight, but yeah, we're well known for being able to get things done. I think there's generally that want to go and achieve things that makes us go and do stuff that other air forces would probably turn around and say, "No, we're not getting involved in that," or "No, we can't do that mission tonight. Sorry." And you generally go out and you find a way to get things done. But I also find that you get a lot more sort of career people necessarily than, like, say, the Americans. They generally stay in it for a lot less on the whole than necessarily we do. But I think that's the main thing. We just find ourselves doing a lot more than necessarily we should for a small island.
Okay. What was your most enjoyable day of work, and what did you do, if you can remember?
I think the best one was the Queen's birthday flypast in 2013. Because I was on Tristar at the time, and they turned around and said, "Does anyone want to come along?" So the flypast you see going down the mall, and have the Queen waving at you as you're flying over. And because we're a passenger aircraft, so anyone want to come along? Took a load of air cadets as well. And so I went on that because I was in work anyway, and it saved doing some actual work. So I said, yeah, off you go, we've got plenty of people. So I went on that, but we were also the only serviceable tanker at the time, and so we were holding the national standby for tanking. So when you see the quick reaction alert typhoons get scrambled, they always send up a tanker as well, because fast jets use fuel a lot and they can't carry much. And we were holding that standby at the same time. So we've been over over Buckingham Palace, and we're busy transiting back up the M40 up towards Oxford, and they get a call that the typhoons have been scrambled. Can you go and sit off the Isle of Man for a while? And so okay then. So they swap crews mid-air and off we go. And one typhoon went and intercepted the airliner, and the other one came up and grabbed some fuel off us. And by the time that had all finished, and the time we actually got back, I've been airborne for 6 hours. That's half my work shift gone. And it was actually a really enjoyable day. I did appear on the news story as well. I was sat in the cockpit at the time, and they were filming, and I sort of stuck my head round and then realised, there's a camera there, and then stuck it back again. But there's footage of that on my YouTube channel and stuff, because at one point we were formating with a VC-10 at 2,000 feet over Norfolk, which is not something you'll see anymore, or not something you're used to see every day. But that was just one of those really enjoyable days that I wasn't expecting to happen. So.
Roger. You'll have to send me your link, by the way, so that I can put it on this video. Did you have trouble with pressurization in the older airframes?
No. It's generally the aircraft can supply so much air to itself that small leaks are neither here nor there. That's just an acceptable thing. There were acceptable rates for loss, and you would test them occasionally, where you pressurize the aircraft, shut off the conditioning, and then basically measure the time it took for the pressurization, the pressure inside the aircraft to run down. And as long as it was above a certain figure, you were fine. The only issue came with if you had really small leaks that started whining because of the airflow going out of it, and usually it was just seals that you could re-grease, and it would be fine again. But on the whole, no. It's the aircraft produces so much air that it's a controlled escape of air to keep them pressurized.
Never thought about that, but yeah, you always just assume they're completely airtight, but it's an interesting thing. Okay, shows the realities of engineering, I suppose.
Definitely. Yeah.
What would be your choice of plane or chopper if you? Oh, right. So you have to think outside the box here. This is a fantasy question. This is not a realistic question. If you could drive a plane or a chopper, what would it be in Fantasyland?
We were talking about this while you were away stuffing your face out. I really like the C2 Greyhound, the carrier on board aircraft.
Oh, I don't know.
The short squat one does all the carrier delivery.
Stand by. Oh, that thing. It's always in the background whenever you're watching a carrier movie. When you're watching your F-14 or about, it's always in the background. I never even thought about it. Okay, well, you're going to have to really try and explain this to our valued viewers, why you want to do this rather than a nuclear bomber or something. Why do you like this?
I've always really wanted to land on a carrier, land and take off on a carrier. That's something that must be an amazing experience. So I could go be engineer or whatever on something like that and just travel around with it. Because I think it's got fold away wings and all sorts, but it's also really old. So it's got that sort of mechanical side to it, which I quite enjoy. So go and fix that and go and fly around the carriers and stuff like that. I think that'd be great.
All right, fair enough. We'll let you off. Very good.
It's not all about fast jets, mate. Yeah.
No, you tried telling the viewers, the valued viewers, that. Okay, we are on 21. Have you been deployed in any of the hot zones around the globe during your service?
Yes. Yes, I have, and my medal collection reflects that. As I was telling you the other day, when there are places you've been where they say you can't tell anyone where you've gone or what you've done or anything like that, and then they give you a medal with the name of it splashed all over it. But yes, I've done Iraq, I've done Afghan. Obviously, I'm not a soldier. I'm not out there shooting my gun or killing people or anything like that. But it's and there's definitely a level of sending an aircraft like that once it's safe enough. Chinook, not so much, but especially something like a Tristar, you don't want to base it somewhere where it's still dangerous. So, the places you go with them are generally safe. He says in inverted commas, in comparison. But yes, there's
a lot of.
It's one of the things I enjoy doing is getting involved in that sort of stuff.
Roger. Yeah.
And not just sort of staying in the UK.
Roger. I mean, Chinooks use the front line quite a lot for medivacs and stuff like that, isn't it? They get shot
yes,
quite a lot.
Yes, and there are things I can't necessarily talk about that have been involved slightly more in that hot environment or whatever than what have been on the other aircraft.
Okay.
But it's that level of it is not a day-to-day occurrence. That was a one special off thing.
Sure. Okay.
But yeah.
Very good.
They basically got to dress up like it was in Dad's army at that point. It looked ridiculous.
Very good. 22. Do you recall any interesting stories that you could share with us from your time in the Air Force? Well, yeah.
I mean, it's every story is interesting. How dare you? Yeah, there's been fun times. There's also, especially when you're like landing in places. I got stuck in Bermuda for 3 weeks at one point with a fuel tank leak. What can you do with that when they're like giving you rates of like $100 a day to go and buy your food because it's ridiculously expensive? But at the same time, I've gone out to places where I've been fully up armed to the teeth with a helmet on, body armor, and all sorts. So it's seen at both ends of the spectrum. But it's the being stuck in Bermuda was interesting because we had to basically empty the aircraft of fuel to be able to pressure test it to try and find this leak, and they wouldn't take our fuel off us, and we had like 75 tons of it on board. So we just had to sit there burning it with the engines until the aircraft was empty. It was the only way we could do it. So I don't worry about my carbon footprint anymore because it's fucking massive out there, and I'm never going to get that back. Not in a month. I could, no matter how many trees I plant, I'm never getting that back. There's all sorts of good stuff going on. We could talk for hours about that.
Okay, number 30. Did you have a good team? Do you work in the Air Force? So, what does that? What's he saying?
Yes, there are great people I work with. You, especially in this sort of job, you always make, and in the military in general, you make friends that you keep for life, even though you might not see them for years because you're in different ends of the country or whatever. And at the same time, you also get to work with complete idiots, and that's not just on the engineer side. That's in all walks of life. That's with aircrew officers, all sorts. It's like any part of life. You get all sorts of people in there. But yes, you do work with some great people, and some not so great. But.
How do you inspect the airframes for structural damage, and to what extent do you cover the whole body and wings?
So generally, that sort of inspections vary according to time. So I'll do inspections, say, after every flight. And you do an after-flight inspection, after-flight servicing, and that's literally just sort of walk around with a torch, visual check of everything. At the opposite end of the scale, when they do like major maintenance, when they'll be going in, everything's stripped out, and they're doing X-ray inspections of structural members of it, and it varies in between according to the manufacturer's schedule. A good one for the if you have an overweight landing, say that can much the same as like an over-G, that can bring in lots of penalty inspections. The Nimrod had one where you remember you had the pod tanks on the wings, extra fuel tanks. If you had an overweight landing, you had to drain them, take off the covers underneath, stick your head in, and check the attachment bolts for those tanks onto the wing, because that was like a known like weakness in effect. So it all depends on why you're doing the inspection, and all these inspections are laid down in the manual as to what you check, when you check it, how often you check it, and what you're checking it for. And that's all determined by the manufacturer and design authority.
Okay, very good. 33. Did you have to redesign or improvise parts or repairs if the airframe is very old, one, or would you just cannibalize one for parts, but those parts are old as well for sure? Interesting. So did you bodge anything?
Designing and improvising parts is not something you can do, because every part is designed with tolerances. It's designed from manufacturer and by the design authority to do a certain thing, and your component has to meet those requirements. It's an airworthiness thing. It's an airworthiness requirement. You can't just go make things up. And any modifications are done by the manufacturer, by the design authority, and if they're going to change it, let's say they change the design of a component, they will basically make new ones, or they will modify ones they've already got in stock, send them out to you, and then you replace it on aircraft and send the other one back to be modified, or maybe they give you everything you need to modify on the aircraft or whatever. But that is done at a pay level that is way above me. You don't just sort of make shit up as you go along, essentially. You can cannibalize aircraft if you have one that's in-depth maintenance and has a component that you need for another one because you haven't got any others in stock because of where you are. You can take that component off that aircraft, as long as you make sure it's the same part number, same modification state, all that sort of thing. You can take it off, fit it to the other one, not a problem. So you can cannibalize quite happily. But even like structural repairs, etc., are fully laid down in the manual as exactly what you have to do. It's all airworthiness. You can't just sort of make stuff up as you go along.
So all modifications, you said, they have to go back to the manufacturer for approval, or have to be designed by the manufacturer, any modifications?
Yes, they will come from the manufacturer based on, I don't know, improvements in design, or discover that a component is failing a lot sooner than it should do, or that sort of thing. And yeah, you will get a modification come out, and you will get a bunch of stuff to either do the modification, or you'll get a new valve, or they say take these off, send them back to us, etc. Whatever. There's various different ways it can happen, but all that stuff comes from manufacturer based on their experience, their testing, improvements in design, whatever. It's not something that we get in with designing. We just sort of carry them out.
What about if the manufacturer, if you've got an old plane and you need a modification and the manufacturer no longer exists, are there engineering firms out there that could take the job on to create the modification?
And this is where your design authority comes into it. Now, usually, if it's a Boeing aircraft, Boeing is still around. Tristar was made by Lockheed. Lockheed is still around, but they will put out all the design authority. They will subcontract it to someone else because they're not interested in the Tristar because it failed for them. So our design authority in the UK was Marshall's Aerospace at Cambridge.
I know very well.
We're also the design authority for the Hercules.
Yep.
And they hold all of that airworthiness side. This is what happened with the Vulcan, because the design authority, I think it was Marshall's as well, actually, basically withdrew support for it, along with Rolls-Royce withdrew design support authority for the engines. So at that point, you can't fly. That's just a fact. Yeah, so they hold the airworthiness responsibility, if you like, for the aircraft.
Interesting.
And that's who you go to do all this sort of things. It's that's not a first line activity. It's but we keep a record of all the changes that have been made, like service bulletins where small things have changed here and there. Like we've taken this P clip off this wiring loom and we've rotated it 90 degrees because it works better that way. That sort of idea. Just a small service bulletin for something like that. But we keep records of all of this, so you can go back to it at some point. But that's all. It's all done by the design authority.
Roger. Okay, very good. A few words of advice to a youngster that is looking forward to following your steps, please. Maybe any things that they should avoid, for instance.
If you're going to be joining as an aircraft engineer, get to a frontline squadron, and depending on what your interests are. Fast jet didn't particularly appeal to me, but then neither did helicopters, but that's where I ended up. Take it all with a pinch of salt, because you are at the mercy of the Air Force. You can't always control where you will end up, either locational wise or airframe type, and make the most of it while you can. It's there's a lot of stuff out there. If you want to get down and dirty and the full on current operations and stuff, then get to Chinooks, because that's what they do. If you want to go somewhere hot, then get on the tanker fleet, because you might end up in Vegas, which I did like 3 times on TriStar, because the fast jets tend to go out there to do training locally out in Nevada, because that's where all the testing for weapons release and that carries out. So I found myself in Vegas quite a lot, which is enjoyable. So there are lots of sides to it, but depending on what interests you, have a think and decide what route you'd like to go down in that way. But whatever aircraft you end up on, there are rubbish jobs, there are good jobs. Found myself in my mid-20s emptying an aircraft toilet. You think, why the hell am I doing this? That's just part of the job. There will be times where you won't be happy. You'll be outside, you'll be cold, wet. I found myself in Norway, in like minus 30, out in a tent, thinking, what the hell am I doing here? I'm 35. What the fuck is going on here? Being yelled at by a bunch of Marines. But it's there are lots of ups and downs. But if it's something you want to do, when you sign on for 12 years initially. But have a plan as well. Don't necessarily say, I'm joining the Air Force, I don't have to worry about anything else for the next 12 years or whatever. Have a plan. See if you may decide after a few years that you don't want to do that anymore because it's not quite what you thought it was. The Air Force has lots of educational opportunities as well. Take advantage of them. But have a plan, but don't center your entire life around it. Figure out what you enjoy. And to me, as an engineer, I wouldn't go anywhere except a frontline squadron because that's where I say action. That's a really horrendous way of putting it. That's where the interesting stuff happens. But that's from me. So, I'm not. It's definitely something to recommend. Yeah.
Roger, very good. 36. What is the future of the RAF in your opinion? More expensive jets and choppers in low numbers and less personnel? ?
Well, we're always getting less personnel, that's for sure. They're basically the idea. It used to be you had frontline squadrons, you had second line bays on it, and then third and fourth line bays which did like component strips and repairs. And effectively, they've gone down the route of anything which is non-deployable. You don't need a bay out in the Middle East. You're fixing a little radar box or whatever. You can make that civvy, and so only like the frontline stuff is generally now. And a limited amount of second line stuff is actually like blue suits, actually Air Force. So it's always getting smaller. UAV seem to be coming in there an awful lot, but I think there'll always be a need for like manned vehicles. That's for sure. Yeah. And the engineers to fix them. It's exactly how it ends up with airworthiness sides of things and how more aligned it will become with the civilian way of doing things. I'll wait to see because we've now got like 2 platforms, one of which I'm on, which requires you to have a civilian maintenance license to work on because they are civilian registered. And there's an argument from my perspective anyway that we should all have that because our aircraft fly in the same airspace as civilian aircraft. Why shouldn't we be licensed to the same standard as all the other aircraft? But that's a whole different kettle of fish.
Okay. 38. What's the most common structure damage that you've had to repair on airframes, and what was the cause of it?
Corrosion is something you find a lot of for various reasons. Nimrod obviously operated low down over the sea. With salt water, and salt water environment is horrific for aircraft. It did get washed every time it came back from that. Like, there was a giant aircraft wash on the taxiway, so it would come off the end of the runway, and it would literally, these jets would come out of the ground, and it would taxi through it, as well as getting a proper in-depth wash every like 30 days. There's a lot of focus on corrosion in that respect, and it's the same with Chinooks because they do a lot of stuff like lower down over the sea, and so like saltwater operations and the stuff you have to do after them was quite in-depth. But you still find corrosion. Everywhere. It's just what metal does. So that's probably the most common I found. And that's common to every frame, to be honest.
Yeah. Just think about a plane that's just an F-14 or something that's going up every day over the and is stored in the ocean. Basically, imagine how much anti-corrosion stuff they must be doing.
Yeah, the main thing there also are the engines. You do compressor washes on Chinooks an awful lot, where you run it up on the starter, so it's going at like 20% or so, just on the starter motor, and then fire water through it to try and clear it out, because you start getting saltwater corrosion inside your engine, then you're screwed. And it's the Navy have the same thing with all their helicopters; they do them constantly. And I imagine it's the same. You get the same sort of thing on a Navy ship, like a Navy carrier. Not something you have to contend with in DCS.
No, thank God.
Mainly because you tend to crash your aircraft every time instead of actually landing them.
We have no intention of getting past more than 2 hours on each airframe before it can be written off.
Yeah, it's not the most cost-effective way of doing it, but it does make my life easier.
We don't care about that. 39. Of all the airframes you worked on, which was your favourite and why? We've done that. Was it just the type that you liked, or was it easy to work on? We've done that, skip that?
Yeah, pretty much, yeah. Cool.
40. Are the hydraulics cooled somehow? And were all the types you worked on operated by hydraulics? For instance, landing gear, flight controls, or on the old ones like the Nimrod, were there cables as well?
So you basically have both on Nimrod, Tristar, C-17, and Chinook. Actually, they all operate using hydraulics to move the controls, but they are input by cables, rods, and pulleys. So even the Chinook, it's a physical control rod from the bottom of your cyclic or your collective that goes up the side of the aircraft, up to the top, through the mixers, and then out to the back, out to the aft pylon, and to the forward transmission, to your swash plates, and they then make a physical an input into the servos to basically tilt the swash plate to get the right angle that you want. And it's the same on everything else. Although you have a massive servo at the flying control itself, it receives mechanical inputs from control rods, cables, or whatever. C-17 was a little bit different. It was primarily fly-by-wire, where the inputs you were putting in were basically translated into electrical signals, and it flew like that most of the time. The servos would receive the signals and respond as they were required to, but it had a cable backup at the same time. I think I didn't do enough work to be precisely certain exactly how it worked, but from what I understand, the primary controls were fly-by-wire, but it had a cable backup at the same time. And it flew, from what I've read, perfectly fine off the cables as well. But there's very little that actually operates purely on a fly-by-wire side of things. A400 is the first one to do it, I think.
Not sure.
And Voyager, which is obviously just an A330.
And
they are purely fly-by-wire.
Any idea about fast jets? I always assumed they would just purely fly-by-wire with no hard backup, say an F-16 or something. I think
F-16, I believe, was well known as the first jet to be out, but which was purely fly-by-wire. Typhoon, I believe, probably is. Everything else, I would imagine, is all like cable rod operated. But yeah, I think you said you had an interview lined up with a fast jet guy, so you're probably best off asking him.
Okay, very good.
Yeah.
Right, moving on to our last pre-asked one. Can you, or in fact two more, can you walk us through through a busy day of work as an airframe technician from start to finish?
Yeah. Oh, actually, we missed a bit off that last one. Are the hydraulics cooled?
Oh, sorry.
Generally on large aircraft they don't have to be. There's enough fluid there, and with the airflow and the temperature outside, etc., that provides enough cooling for you not to need any sort of active cooling, if you like. Chinook was slightly different because it could quite happily sit there in the hover. The generating like no airflow. It had matrices which had fans on the back of them. If the temperature of the oil got past a certain limit, the fans would come on and keep it cool. Generally, they didn't have to, because as long as you've got airflow going over them, you're all cooling the hydraulics. But because you could sit in the hover, generating no airflow for an infinite amount of time, you had these fans on it that would keep it cool as well. So
interesting.
Yeah. So what was that next one? Normal day. Oh god. Essentially, it's on a line squadron. Your day usually consists of either dealing with the flying program or dealing with the engineering side of things. If you're dealing with the flying program on Chinook Squadron, you start the day, get the aircraft that are going to fly out of the hangar, get them serviced so that all your oil levels are correct. You've done a walk-around inspection, get rid of all the blanks and all that kind of thing. Prep them for flight, fuel them up, and then see them off. So you're there as there with your fire extinguisher, looking like you know what you're doing. And if they have faults on them during startup, you'll go running out looking as though you know what you're doing, and try to convince the crew that it's okay to take, it'll be absolutely fine, with as much confidence as you can muster, unless you've only just arrived there, which is, it definitely happened to me, where you've literally been there like 2 weeks and they send you out on a crew in, and you haven't got a clue what you're talking about, and all you can do is like nod and look as I'll just go and double check something in the book, as you run in and say, I don't know what he's talking about. Because although the crew are generally on the aircraft for most of their career, we can switch about quite a lot. So you find yourself in some interesting situations. So the aircraft will go flying. They'll come back a few hours later, and you can either do a turnaround servicing on them, or you can do a full after flight. You stick them back in the hangar and deal with that side of things, or you can be go into the trade office and you're given a job to do. And so this is what you're doing today. You're carrying out this check on that aircraft. This aircraft needs an extra fuel tank fitted to it. And you have like a full plan in place for what your day is going to consist of. And then the day generally never goes like that at all. And you'll be dragged from one job to the other. You can say, there's no one to go and do the screw and snag, even though you're halfway through fitting a blade or something. And so can you just go out to the aircraft and check it, because there's never enough manpower. So if anything, one of the more enjoyable parts of the job I found was the fact that you never knew what you were going to walk into. And it constantly changed throughout the day. So no 2 days were ever the same.
Okay.
But yeah, that's more frontline stuff, where you are either out working with the flying program aircraft, or you could be in the hangar doing basic maintenance on the stuff that's in there. If you say go second line and work with depth maintenance side of things, where the aircraft goes in there for a few weeks, gets stripped down, inspected, and put back together again, or whatever. It's not the sort of thing I particularly enjoy. For some people, because that's more 8 or 5 Monday to Friday. That's it. No weekends, that sort of thing. It's more structured. Maybe people have families, that sort of idea, but it's not the sort of thing that particularly interests me. I prefer like the more interesting side of like the frontline stuff.
Very good. Okay, have you got time to take some live questions?
Yeah, go on then. We've wasted almost 3 hours already. What's another few minutes?
Guys on the Discord, any questions that you guys have got? One from the stream. How does the Chinook hold up against large bird strikes? I'm assuming that means in the engine. I assume it has no effect already, but what's your...
Generally, the birds get chopped to bits if they happen to go through the disc. And then the biggest problem there is the fact that all the remains are liable to go onto the windscreen.
Oh, nice.
Yeah, and then the engines have generally got guards on the front of them. You go back to the footage from like the Vietnam War, and they've got nothing on the front of them, so anything that went down there would like trash the engine. We have various different guards you can fit depending on what environment you're in, including ones that are work on like the massive idea of basically the massive vacuums to get rid of any shit that comes in, like sand, and keep it out of the engine. They're specifically for sandy environments, but yeah, generally your helicopter's not going fast enough to suffer any like major damage from something like a bird strike. So and I say they normally get chopped up fairly well by the rotor blades. It's just finding all the bits of them down the back end that can be a bit of a challenge.
How does I don't know if you've got anything on this, but how does the counter-rotating blade chopper, like the Camel family, controlled? Same concept or completely different, or don't know?
I actually did a bit of reading up on this, because I had no idea when I first saw you flying it around in DCS. Effectively, it works the same sort of way. You just have to make sure that basically the top blades, if they're in their fully like down position, if you like, because when you produce lift, the blade disc, if you like, goes up into a cone, because the blades lift themselves up and then start taking them out the helicopter. So if you've got your two above them, and you don't want them intersecting each other because they go in opposite directions. And it's the biggest issue I tried to get my head around was how you do yaw in a contra-rotating system like that. And the answer I found effectively is that because you don't want to change the amount of lift that's being produced, so you produce more lift on the top rotor blade and less on the bottom. And because by producing more lift, you induce more drag on it, that would normally cause that rotor disc to slow down. And because the bottom one doesn't do that, you get a torque moment induced, which tends to spin the helicopter in a specific direction. So if you want to yaw, you increase the lift on one disc and reduce it on the other. So you keep your total lift the same, so your helicopter keeps going in a straight line at the same height, but the change in torque between the two of them causes the helicopter to spin. Interesting. That torque is normally offset on a normal helicopter. It's taken out by the tail rotor, and on a Chinook, it's taken out by the fact that the heads spin in opposite directions. But obviously, on like the Alligator, it's a case of it's normally not there unless you change the lift that each disc is producing.
What's the main? Sorry, go ahead.
Yeah, I don't know who came up with this idea for it. It's utterly ludicrous.
That's what I was going to say. What's the main? I mean, they've had to. There's obviously a big advantage for this type of system. If they're going to go out and engineer it, what was that? I've never found the big advantage of it.
It's compact, I suppose. I don't know. I'd have to go and Google exactly what the advantages are, because obviously it's not something we have.
No.
But it keeps it compact. Obviously, the Chinook's quite a big bit of kit. But that's the only reason I can think of. Is because without having 6 blades on one rotor head, because things become a bit more complex then, because you've got a lot of kit to get into quite a limited area. So by splitting it across 2 heads, you have a lot of space then. But yes, it's I can't imagine it's an easy thing to engineer.
No, not
like
at all.
that.
Okay. Any idea if lightning strikes are more detrimental to choppers than they are jets, or are they just as harmless?
I wouldn't say they call them harmless either. It depends on what they do, because they generally will find their way through pretty much the most expensive component you can on the aircraft. And it's yes, it can mess up your electrics quite a lot. It depends on how vulnerable, how susceptible your fly-by-wire system is, effectively. So if you have no mechanical backup, I imagine it could be a problem, but it's the sort of thing I would like to think designers would design into their aircraft a system to protect against it. So that if the lightning does strike the aircraft, it basically avoids all of your electrics, all of your really important stuff, and gets thrown out the back end. That's, again, is something I have experienced. I've seen lightning strikes on aircraft, and they do generally, for some reason, always come out the most expensive component, and leave scorch marks here and there and everywhere. But mostly, it's like your car; it's a Faraday cage, so it will generally find the easiest way is just round the outside. That's why your car is the safest place to be in a lightning storm, because it will go around the car and out the tires before it goes through you.
You have leading edge heaters on wings to stop the icing. Do we have the same thing on the Chinook and/or helicopters? Never thought about it.
It is a thing. The rotor blades can have de-icing strips put on them. We don't have them on ours. We don't fly in that sort of weather enough for it to be an issue. But it is a thing you can get for them. I think our blades have got the connection points on them, but that's just a standard part of the blade. We don't actually have them on ours.
I was just wondering if the centrifugal forces will deal with it. Just shove it off.
To an extent, it's it's whether you've already got it on there or whether it forms in flight. And like you say, the forces that are going through it makes it unlikely to form on it. But I suppose if you're in a specific set of circumstances, temperature, humidity, whatever, I suppose it probably can form in flight, and because otherwise they wouldn't put this stuff on the blades. But it's not something I've seen, but I know it is a thing.
No, John. Do we know if this chopper? I mean, I don't see any reason why it couldn't. But any problems with this chopper auto rotating? Do you know?
No. Well, yeah, we did, that was part of the question.
I thought I heard that.
Yeah, the Chinook can auto rotate quite happily. I think I put a comment on one of your videos actually when you did the auto rotation composition. Yeah, the Chinook does the same thing. Effectively, the collective is rigged so that it goes from neutral to fully up if you want all the lift possible. If you want to go less than neutral on the collective, you have to push through a detent that Boeing have put there again and fight against a spring, because generally you don't want to push down on the collective and produce negative lift. That's not something that generally you want to do in a helicopter. It results in fire and death and that sort of thing. So you have to force your way through it, and that detent is put in a neutral position, so that's where you put the collective when you want to start up, so that you know that when you start, the engine's head starts spinning, and their blades won't produce any lift at all, because you don't want to suddenly find yourself flying off the deck. So if you do need to auto rotate because you've lost both engines, you dump the collective fully down, and we have rigged that so that the blade angle it adopts as you start falling through the air will be such that it maintains within a few percent that 225 RPM. So the crew can adjust it as they fall through the sky, but generally it's set up so that you just go fully down and they just leave the collective there. The helicopter will fall and maintain that rotor speed at that speed, because that rotor speed provides you with your electrics, and it keeps all your electrics going on the AC generators. So that's the other thing you want to keep going. And then as you approach the ground, you do what you normally do, and you just pull up and change all that rotor speed into lift to arrest your descent as you then pull out and hopefully land.
Okay. The whole idea of having a constant speed rotor is so foreign to what I'm used to, or the way it
It
works.
is. It's
anyway.
yeah. It's. I didn't really understand helicopters before I got to them because they're not really covered in training as such. But it's you always just assume that you hear the engines going and the rotor blades must be changing speed to change what the helicopter's doing, and it's not. It literally is. It stays at that one constant speed all the time, and you just vary the pitch angles of the blade, of all the blades as they go around, to change what you want the helicopter to do. But yeah, that constant speed is the main point.
Roger. How long will a set of blades last? I'm guessing you're going to say until they're damaged.
Yeah, they do have lifetimes on them,
Okay.
at which point they go back for inspection. But generally, they'll either have they might develop. I've seen one like with a crack in it, or they can hit something and be damaged that way. If you're in a really bad environment, sandy environment, then obviously the erosion causes all the paint to come off them. But we do fit anti-erosion tape to the front of them for that sort of environment. But yeah, they do have a lifetime on them. I couldn't tell you what it is off the top of my head. But again, based on flight hours. But again, they get inspected after every flight. So yeah, it's they're more like most things. They're more likely to get changed for another reason than just being out of life. And
I thought that if something's going to get hit, it's going to be that, I imagine. So. Yeah. Okay, guys. On the voice chat, any last questions? Last chance.
Thanks for the educational thing. I learned a lot. Also, Cap, please check my messages. I left you also a meme.
Roger Wilco. Okay. Told him. Yeah. Miranda wants to speak to you, but is that privately? I'll take that as a yes.
I think we did have a small chat.
Oh, you've already
sorted
yourself out.
while you were having lunch.
That's fine, guys. Right. Well, thank you very much for giving us your time. You're a very busy man, hard to get hold of, like everyone in aviation.
That's going to be a nightmare for you to edit because that's like 3 hours of us chatting shit. Essentially.
That's okay. That's what I get paid for, kind of. Thank you very much. We'll be in touch whenever we be in touch. We always cross paths one way or another, don't we? So
I'll just put it on tape there.
Okay.
Quick thank you to Ben Ford for all the guys that actually fly around the back of those
I have
big beasts of his.
another question.
that was a thank you from Davros for the guys that fly around. And Miranda, send quickly, please.
Cap, will you save this? Can you save the live stream?
Yes.
Save the live stream.
Yes, that's fine.
Like we can play it again.
Yeah. Okay, we'll get that done.
Cool.
Okay, Martin.
I've just sent you. I've just sent you one last picture, mate, which I forgot about. For those interesting, and when you were talking about the couplings on sink shafts, so that is those are the sink shafts running from the combiner at the back to the front transmission. So there's 7 there, and those are what are driving the forward rotor head.
Wow, they're massive.
I am so glad I knew nothing about this when I was flying.
Send me also the picture, please.
That's amazing.
And the silver rods on the right hand side, those are your flying controls.
Yeah.
Which are taking the out of the mixers, which deal with all your flying controls. I'm not going to go into that because that's just horrific. Yeah. And those are what are putting the input to the flying controls at the back, and they're just basically running along the back spine of the spine of the aircraft.
Roger. Excellent. Right.
And you can see the filters on the front of the engines there as well.
Yeah, which can change on different environments, which I didn't know. Learned a lot today, guys. Great. Okay, I shall crack on. Martin, thank you very much, and the rest of you guys will catch you later.
Okay.
Excellent. Cheers, guys.